Fantastic theme music this year. I'm very impressed. So welcome, folks, to the EMEA leg of this year's DevSecCon24. My name is Matt Jarvis. I'm Director of Developer Relations at Sneak. And today I am joined by my lovely co-hosts, Andy Martin, who's the CEO of Control Plane, and Jamie Thomas, who's Community Manager at Control Plane. Thank you, guys. We'll be talking, I'm sure, a lot more during the show. So I hopefully some folks are still here who watched the APJ section this morning. It was slightly early for me, but I'm planning to catch up with some of the sessions on the replay. Those will be up on YouTube imminently. I thought there was a really interesting session I was looking forward to about security champions. So I'm going to be catching that, or maybe I'll catch it in one of the breaks this morning. So before we get going, a few kind of housekeeping things. So if you're watching on the Hopin platform, just to give you a couple of pointers on where you can find things. So all of the schedule is on the main front page if you click on reception. You can also put stuff in the chat. You can ask questions of the guests. We'll all be monitoring that chat, picking up those questions, passing them on to our guests. So please do contribute there. If you need anything at any point during the conference, if anything has made you feel uncomfortable, for example, or something you'd like to raise with the organizers, you can join the Discord server, and the details for that are on the DevSecCon DevSecCon.com webpage. We'll put that up on screen in a second. Please do visit all our lovely sponsors. Without them, this conference could not take place. So you can find all of their booths in the expo section of the interface there on Hopin. So please do go along, visit them. I'm sure some of them have got some great stuff that they give away, and you can see demos of their fantastic products and have a chat with those folks. So that would be great. And I think that's maybe it for our intro bit. So do we have our first guest yet? No, I don't think they've arrived yet. So what the other thing that would be great, we've got the DevSecCon awards coming up. So if you are interested in nominating folks for those community awards, if you go to devseccon.com/community/awards, these are a fantastic thing we run every year, and you can nominate folks for a whole selection of awards that are voted on by the community. So please do go along there and have a look at some of those. So Andy, whereabouts are you in the world today?
I have just flown into Berlin recently for the We Are Developers conference.
Yeah, fantastic. I love Berlin. It's a great city.
It's beautiful. The sun's out. The birds are singing, and there's lots of high quality content in there as well. But of course, this is the prime conference of the day, and I'll be attending that one tomorrow. This one today.
Maximizing my security. You're speaking over there, are you?
Yeah, I'll do actually the same talk that I did for DevSecCon earlier in the year, and KubeCon as well, which is the Hacking Kubernetes live demo marathon, which has gone spectacularly wrong before. So looking forward to a slightly less sort of fear-inducing, stomach-churning run through tomorrow. These fingers and toes.
We can get the fear-inducing, stomach-churning stuff out of the way today, right? These live conferences are all flying by the seat of your pants, so I'm sure there'll be plenty of those moments. So without further ado, I would like to introduce our first speaker. So perhaps if we can bring Pete onto the stage here, Sam. So Pete, good morning. Well, good morning. I'm not sure where you are in the world, so I don't know what time zone you're in, but
Eastern time. I'm in Florida right now.
Right. Okay. So it is good morning then, just about.
For sure. For sure.
Okay. Brilliant. So Pete's the CISO of for North America at Checkmarks, and I will let's get Pete's slides on the screen, and I'll give Pete the stage. So Pete, thank you for joining us, and I'll let you crack on.
Excellent. Thank you very much. And thank you, everyone. It's an honor to be here today. I'm excited to talk about how we can get better together. So as stated, I'm a CISO of North America at Checkmarks. I am of Tribe Developer, and that is my career. I happen to be in information security right now, specifically application security, but I really, my passion is around development. And it's funny that in security, it's often not about the tech. It's usually about people and process, same as it is in development. So I want to talk to you a little bit about that today. A little bit about Checkmarks. We are an application security company. The finding, the fixing, the preventing, looking at your applications, which have changed over the last 15, 20 years. That definition of an application has just grown and exploded. The number of things that developers need to be aware of and security professionals need to train on it continues to expand. Of course, one of the things that I think about with development is hygiene, but not, as was suggested in the talk, the kind of, I've been up all night, which I have done, and been at the computer working hard on a problem, sometimes in the office, sometimes at home. It's more for me about how we think about our process and how we think about getting better. Do we have good habits around how we create the software that we're paid to build? Now, I'll start this talk with feedback. And this is a bit of a cheeky talk, as you can see by the title. But, feedback is a gift if you choose to take it that way. And, I've given a lot of talks around feedback. And one of the keys here is that you should ask. So I'll ask you to be receptive of this feedback and not take it the wrong way. It's not meant to be a weapon. It's not meant to hit you on the nose with, because we can only get better if we understand the things we're deficient in. And those are very hard sometimes to look in the mirror and say, yeah, I'm not my best self, or I didn't do my best job here. So this is meant, this entire talk is meant to really take a look at ourselves, how we do business, and whether or not those are the right things that we should be pursuing. Critical to improvement is to be able to take a step outside. If you've been in your company for a long time, I've been in a company as long as 12 and a half years, and it's very hard to look at what you do on a daily basis and understand whether or not those are still the things that you should be doing. The traditions that you build up, the norms that you build up in a company, even if they were right at some point in time, the old saying, what got you here won't get you there, is absolutely true. So to be able to look critically, and sometimes this requires a friend, someone from the outside, maybe even someone that you hire to come in and have a look. Let's inspect what we do, and let's be clear-eyed about this. So we'll start by looking in the mirror. What do you think of your own capabilities, your team's capabilities, your company's capabilities? Are you honest with each other and with yourself around what you can accomplish and what you can't? And it's okay to be deficient in something. It's okay to struggle, but it's really not okay for you to have this fake image of yourself where, yeah, I'm a Superman, we could do anything, don't worry about it. That doesn't lead to good outcomes. And if you look at the goals that you have for your sprints, for instance, if we take a look at a sprint, do you do stories in, stories out? Are you completing the definition of done? Are you really looking critically in your retros to say, hey, how could we be better? What really didn't go right? Instead of being, about patting yourself on the back. Key to software development is to build muscle in the right areas. So I coached soccer for 15 years, from the time my children were 4 years old until they were freshmen in college and turning 19. The key to soccer coaching is that you need every practice to look like a game. The pieces of the game. It's not the entire game, but pieces and parts of this. Oftentimes, I would see coaches taking their kids up to hills and running up and down hills, or running in the bleachers. But I can tell you from seeing lots of soccer, I've never seen it played on a hill. I've never seen it played in the bleachers. So my question to them is, what muscles are you building for those children right now, and how will that help you in the game? No doubt they're building some endurance and they're building some muscle, but if you don't make it look like the game, then those muscles aren't going to help you in that context. So think about that. In this case, are our lower environments, our development, our quality, staging, UAT, etc., are those done exactly the same way that you do production? Because if they're not, then I would ask you, what are you actually testing, and what value does that testing provide? And if we talk and lean into testing now, and this is less true in DevOps, when you think about test-driven development, definition of done, teams tend to be better these days than in the past around their testing habits from a functional perspective. But if you look at security specifically, when are you testing for security? Are you bolting the engine on the plane and then saying, hey, what could possibly go wrong? Well, that is a way to test, but understand that when you do it that way, you're finding a whole bunch of things at a time when you're really not capable of dealing with them. And now what? Now what are we going to do? So the theory and the thinking around testing, no matter whether it's functional requirements or non-functional requirements, if you look at Toyota production system, when's the earliest we could have found this? How could we have prevented this? Can I find a way to find this earlier, to take risk out of my story such that I can deliver it during my sprint? So when we test late, what happens? No one fixes everything that they find. That includes quality too. I've been shipping software for a very long time, and I know that quality bugs leave. This is good enough. This is close enough. It's time. We need to ship. But if you think about how you test, what you test for, and what your capabilities are you testing for too much? So in security, you could look for every security vulnerability that the security tooling could find across all of the different areas. So you think about infrastructure as code, containers, API, you think about your static analysis, dynamic analysis. Those can find thousands of problems in your code. And the question is, and this is to the security people as well, what is your policy? I often talk to people about their security scanning and their security policies, and what they say is, well, we want to fix everything. And then if I ask them, well, what are you fixing? Well, we'd like to get to half of the highs by the end of the year, which means that we spend a great deal of time looking at things that we're not going to fix, looking at things that, frankly, we're not capable of fixing. So if you're scanning for everything, but only able to fix a small fraction, well, it doesn't mean that you don't want to fix those things, but if you're not capable of it, then you end up bailing these things up at the end of the release, talking about those exception processes and making sure that you can push this thing out to production. And then if you look at your aggregated tech debt over time, it's not a pretty picture. You end up with a Jira backlog full of vulnerabilities that and flaws that, frankly, you're probably never going to fix. And I remember as Scrum Master, as team lead, going back through those once or twice a year and just truing up with myself, saying, this isn't going to get fixed. We need to push this out. We need to get rid of this. We need to say this won't be fixed. So if you think about what you test for and your capabilities, those should line up closely. It's okay to lean over the line and say, hey, we're only able to fix highs, so we're going to do highs and mediums, or some portion of those mediums. We're going to start to keep track of those and measure those. We're going to start to build out our practices on how we get better. Because what's inevitably going to happen is something like Log4j. And in that case, because people didn't have the right muscles built around incident response, all of your development was upended. You said, okay, everybody stop. Let's look for what we have here. And in the case of someone running this incident, as a lead of AppSec, so I used to run application security for the Bank of Montreal, and I was responsible for over 2,000 applications. I would have to say, all right, let me look at the entire list of all the applications I have. I need to break these into 3 different lists. Things that I know are vulnerable, things that I know are not vulnerable, and things I'm not sure about yet. And then eventually you have to work those lists down to everything's not vulnerable to end this incident response. So you're going to teams, asking them, do they have this version of the software, and what are they capable of doing in that case? But because we didn't have good hygiene habits around being able to upgrade our software, these became very difficult conversations. And I know from experience in talking to my peers, sometimes in months, we're measuring these on calendars. And that is not DevOps. That is not Agile. So let's take a look at this and understand why. Now, of course, from a security perspective, I look at open source and I think about this as one of the scariest places for a company. And that's because if you're in a company that has a security practice, there are controls around your first and second party software that hold you to account for some level of standards. So we have scanning, we look at it, here are the vulnerabilities, here's what you're supposed to fix. Now, whether you fix them or not, we are at least aware of them. We vet the employees that we bring into the company. In the case of open source, that's not the case. I didn't hire these people. We don't scan their software in the same way. And these things get brought in to build our applications, and it accounts for 80 to 95% of the software that we ship, which is extremely scary for a security professional because I don't have controls around that. And when we think about open source, we consider it a free lunch. I take it in, I use it, and I don't have to worry about it. But open source is really more like a free puppy. When I decide to use an open source library, I now take on some responsibility to my company, and that's both from the development point of view and from the security point of view, to give it care and feeding. Now, you don't have to do that, but that's animal cruelty. We have to think about what responsibilities we take on when we use this software. And as a developer, I know, because I've done it, we integrate and abandon. It does what I need it to do, so I don't need to look back. I can say, hey, job done, product functions. I have important things to do. I've got a huge backlog of stuff to get after, and tech debt is not top of my concern because this library, it works. But this software continues to grow and change and mature in ways that are sometimes good, sometimes require a great deal of change. If you think about, it's for instance, S3 buckets, when those were created, Amazon really had no idea how they would be utilized, what kind of configurations were necessary. Developers got in there, started pulling it back and saying, oh, look at all the cool things I can do. The same is true of any of this software out there in the open source community. We find new and novel ways to make use of it. Now, sometimes we're going to find vulnerabilities have been in that code since day one, 0 days. And we're going to say, oh, we need to make a change. Now, it's not to say that, that as we use this software, these things come to light over time, sometimes decade or more that this vulnerability has been in there. So there are ramifications to that where I'm going to want to upgrade this, but also as this software changes. So if I go from a version 1 to a version 3 or a version 4, it may change the way I have to package my application. It may change the way I have to do authentication. APIs may have been updated. So when I go to upgrade these, they may be a big change. And in these kind of incidents, if you are writing Java software at the end of last year, that you're under a great deal of pressure. The business is in jeopardy. There are attacks going on presently, and we're afraid of them, and we need to get it done. So we're going to the team. We're saying, you have this vulnerability. We need you to upgrade. When can you get it done? And that kind of constant pressure as an incident response leader, I would have been in a daily meeting with our CISO to talk about where we were, what progress was being made, where I'm being blocked, the help that I need. And then after that meeting, the rest of the day would be in phone calls and meetings to go back to those teams and understand where we are and what we're going to do and how they're being delayed or what kind of problems they're having. So that is not a productive environment. That is not a place where doing things that are normal, if it's an abnormal act, if it's something I haven't done frequently, which is the reason for this talk, if I don't do it regularly, it becomes an unnatural act under pressure, which is not a great way to get things done. So there's a continuum of how you might experience this from the easy button all the way over to it upends everything and all work stops, releases are delayed, bug fixes don't happen. In the case of this particular one, Log4j was released several times where it's like, hey, we need you to upgrade to the, oh, wait, no, that didn't work. Okay, let's go to this next. Oh, no, that's not the one. Okay, here's the real one. There were also ways to mitigate these vulnerabilities. So there was a lot of churn and change happening at the same time. And again, if you're not used to making these changes, then these are very impactful to your program. So what can we do about this problem? How can we think about this in a different way that allows us to lean into good practices that allow these to become normal occurrences? And the first one, which is going to be typical for, I hope, for our audience here, if you think about Agile, if you think about DevOps, DevSecOps, having that learning culture, that continuous improvement, always being constructively dissatisfied with where you are. Hey, we're very happy with where we are, but we want to be here, and I want to go in that direction. Understanding that failure is an opportunity to learn and not a time for us to have a witch hunt. These are the things that I want to be baked into my company's culture and my team's culture. And if that is not the world that you live in, this should be job one. of saying, hey, we're here to learn, we're here to get better. I can't know everything. And as we go, we need to understand that failure is absolutely an option, and we're going to learn from it and get better at it. As you think about technical debt, oftentimes this is the last thing that gets considered. You have a giant backlog of work and a constant pressure from the business to deliver on that backlog, to bring out new functionality, to move the business forward, to enable customers, to enable sales, to make money for the company. And all of that is great, but the second that you finish writing that software, it's technical debt. It's aging on the shelf as it's being used. Now, in the case of open source, I think about it from a drift point of view, that you're drifting from current. So if we go back to that thought of integrate and abandon, if I integrate version 1, and then version 1.1 comes out, and version 1.2, or version 1.5, and then we're up to version 2, I'm drifting farther and farther away in time, in implementation, from the current version of that software. And if I'm forced to upgrade, but I don't practice those upgrades, this is dissimilar to thinking about, I often hear the company say, well, we need to be able to roll back. And if you deliver software and think about your roll forward plan, my upgrade, so I build an increment and I ship that increment to production, whether that's a single piece flow or whether that's the end of a sprint or whether you're doing waterfall, I'm making a change and I'm moving that change into production. If you think about what it takes to get to that point, all of the testing that has occurred to get you to the point where you can do an upgrade, now they say, hey, we also want to be able to downgrade. Well, shouldn't we test that? I have done downgrades in a crisis when I've created an outage, and it's no fun. You're doing a little bit of guesswork. You're working really fast on something that really should have been practiced. So if the intent from a company perspective is we always want to have a downgrade path, then as an engineering leader, I want to make sure that my teams practice that. That becomes part of the definition of done. Have you proven that you can move the software forward and then move it backward successfully? Because if you don't do that, then all bets are off. Same is true here. As you think about moving that software up, is it a breaking change? If I upgrade a library from one version to another, I mean, Log4j is a very simple example that does a very simple thing, but there are more complex examples in open source where if I move it, I have to make a bunch of changes to the software. And if I need to move it back because it broke something, I'm going to have to undo all those changes. So do you have the right level of testing that says, if I change this library, everything works or not? Because if you don't, then we should have a look at that. But think about making sure that you've built the muscle that says, I'm going to keep current to some degree of current, or I'm at least going to measure it and understand it. A couple of minor versions, never a major version, those kind of things. So those are the things that I want you to think about. And now we get into that hygiene. You could buy a car, and the manufacturer will recommend for every 3,000, 5,000, 10,000 miles, depending on the kind of oil, the kind of car, you should, keyword is should, perform that regular maintenance. Now, the great thing about regular maintenance in this sense is that it can be done at a time that's convenient to you. You get to pick when this maintenance happens because we're not in crisis mode. It is inexpensive. And we could talk in terms of software, but in terms of cash and money for an oil change, $50. And it takes a very short amount of time. 15, 20 minutes, oil change done, I move on with my day. It allows the car to operate better for longer. Now, if I choose not to do that, as in the case of software, then what's going to happen is all of a sudden that car is going to stop working. And I don't get to pick when that happens. So it could be at the most inopportune time in my life. It is now going to be very expensive. It's no longer cheap. And the amount of time it's going to take to perform that maintenance to get that car running again is going to be measured on a calendar. So incredibly inconvenient. This is what we do in our software practice sometimes when we don't think about technical debt, we don't think about upgrades, we don't think about moving our architecture, our designs, our deployment patterns along with the times, such that what would have been inexpensive to move between minor versions of an open source library now becomes a major uplift to make a bunch of change that could cost months of time. You should look at how long it's going to take you from the time that someone says, I need to make a change, to the time you're able to implement that change across whatever it is. So again, you're accruing technical debt in a number of areas. You're accruing it architecturally, you're accruing it in the open source that you're utilizing. Your process as a whole, are you doing waterfall? Are you doing agile? Are you doing DevOps? How much time would it take you if someone dropped into your sprint and said, hey, critical, downtime, whatever, how long would it take you to implement that change and get it to production and feel safe about it? I mean, anyone could make a software change and push it and hope, but that's not the way we run a good business and a good engineering practice. So what would it take to move from there to there? So it's about building the right muscles. Again, if it looks like the game, if you practice like you play, if your lower environments and your testing are all happening in an automated fashion and they look the same, whether you're doing a development test or you're doing a quality test or you're in your staging environment to production, if all of those things are scripted and run headless and run the exact same way, such that if you find a mistake, you can move that mistake backwards in your testing lab. Those are the muscles that you want to build. Being able to upgrade those libraries because I have quality tests around them that say, I understand the usage of this library, and if I make a change, I can now quickly test and ascertain whether or not that change is going to break my implementation. Those are muscles you want to have, and be able to now quickly cycle through and say, on a quarterly basis, so similar to what we do in IT, am I doing patches? Am I doing those upgrades? Am I saying, well, I don't want to do it all the time continuously. That's not really relevant to me. Maybe I'll do it monthly, maybe I'll do it quarterly, but it's planful. I understand the debt that I'm accruing, and I'm now going to take that and pay down that debt over time every quarter, which means that I'm building that muscle around those upgrades. Think about the objectives that you want. Think about what KPIs do you have that understand this? Are you measuring the amount of technical debt that you're accruing? Do you have that ledger that says, here are the things that are now out of date? Here are the things that need to be put somewhere in a sprint at some point. Now, it's okay to decide that you are going to accrue this debt. I often think about when I bought my first home. You move in. I don't have a lot of money. I spent most of it on buying the house in the first place. I now am faced with a house full of empty furniture. Well, I'm going to go out and get some credit, and I'm going to start to fill the rooms. I don't fill them all at once. I prioritize things. I say, this is important today. I want to have a nice kitchen set. I want to have a nice place to entertain. Maybe I'm sleeping on the mattress on the floor for now. I don't care. So these are the ways that, in your life, you think about managing debt. Apply that to your software practice. Be mindful of what you do and be able to pay that down, or at least understand how much that's going to cost if you have to pay it down. So as you look at that continuum from where you are today by looking in the mirror to where you want to be, in that ideal scenario of upgrades just happen magically, I take the latest version of open source and I just roll it in, I run my tests and I deploy it into production continuously. Well, that's great. If you're not there, then understand what it's going to take between those two, and then pick that point where you're actually going to land. How much money are you willing to spend? How much effort are you willing to put in? How much change are you willing to make in the way that you build and deploy your software to get you to that point, and then do it? So really, this talk has been around building out the right habits and building the right muscles that can help you in those crisis situations. The worst thing you can do is walk away from a crisis and run back to work. The best thing you can do is to lean into that, to say, what could we have learned from this? How could this have been better? And that's really what I want you to take away from this. So I appreciate your time, and I'm happy to take any questions if there are any.
Hey, Pete, thanks for that. And thanks for getting up so early. It's one of the things, it's not even breakfast time there yet, is it? It's an excellent job.
It is not, but I have coffee. That's the important part.
Power through. So there are a couple of questions. So I'll put these on screen as well. So Ikram asked, how much of technical debt and the current state of application security is down to developer talent debt, i.e. people who are fixed in their ways, won't update their skills? And secondly, how can non-decision makers, I guess, like Ikram, influence that situation as well?
That's an awesome question. And certainly, you know, as we look at how development and the very definition of an application has changed over time. It used to be about my first party code and second party code. Now we introduce open source. We have to introduce infrastructure as code, you know, where I'm now picking the container and the operating system that I'm running on. I need to harden that. These are things that developers never had to think about. So it's definitely a talent debt. Measuring the places that you fail, understanding where you want to be and what it's going to take to get there, understanding you're not going to get there overnight. But this is about being mindful of where you are and mindful of the goals, and then putting the effort into the right place. So this needs to be a business decision, because you know, it's classic that what you want for your development teams, and as a development leader, I strove to do this, but it's super hard. You want a day where people can unwind and think. But having a 5-day sprint be actually 4 days of work and 1 day of mental work, who buys that? The business looks at that and say, why are your developers sitting around? Why aren't they doing things? I'm like, they actually are. And, you know, you have all this evidence that proves that. That they're actually better doing that, but that's not the way you typically run. So it's about having that ledger and saying, look, we're building this stuff up and this is going to be bad. I look at that Log4j example to say, that's a perfect example about why we should be building these muscles. So, you know, writing it down, making it visible, and talking to your business leaders about it.
Yeah, for sure.
I particularly enjoyed many of your extremely vivid metaphors in that talk that I may well have to steal for future talks of my own. The free puppies, not free lunch, and open source age is like milk, not wine. They're both my favorites. And of course, the sport's called football, but I'll give you that.
All right. Yes, I am in love with that sport. It is the beautiful game. So yes.
I mean, I think it says something about, you know, the state of sport in the US when people start actually talking about soccer in conference presentations, as opposed to, you know, I'm sure that probably wouldn't happen 15 years ago.
Well,
right?
It is an EMEA talk, so you know, yeah. that is topical.
So Jamie, have we got any more questions for Pete?
So one from me, actually. So you said early on that feedback is a gift. So what effective ways are there to prepare someone to receive that feedback? Because it's, I guess, if you just wade in with it, they may not even want to hear from you, right?
Oh, absolutely. Yeah, and that is a critical aspect. So thank you for the question. You have to ask. You have to read the room. So, you know, if you're with a buddy who's doing a presentation and it goes horribly wrong and you can see that they're seething, that is not the time for them to be mentally capable and ready to take in this feedback of like, oh, great, it was worse than I thought. So you need to be mindful of the fact that it's not always the right time. You need to ask to be invited. The key here is, if I ask you and you invite me and say, yes, I welcome the feedback, then it's really on them to take that feedback as is, be constructive, but understand that even sometimes when they get that feedback, it might rub them the wrong way. And I've had that happen to me where I have asked to give feedback. They've said, yes, I want it, but what they were expecting was the pat on the back. That's not what I was delivering at that time. So, you know, this is one of those things where they need to learn that, look, say no. I'm okay with no, and you have to be okay with no to either cycle back or maybe never cycle back. Some people don't want it. Some people don't want to hear it. But yes, it's a great question. You should always ask.
Absolutely. And I think timing's important with that as well. I listening to a podcast, the You Are Not So Smart podcast. It's well worth checking out. It's about psychology and things like that. And they were saying the example they used with feedback was is about timing as well. So the example he gave, the guest on there said that he'd been to see a friend who acts and the play wasn't particularly good. And the friend comes rushing up to him after the show and says, how was it? How was it? So he said he wasn't going to lie, but he wasn't going to give her the brutal truth either.
Oh, we lost Jamie there.
Well, at least he ended in a smile.
He just said that I enjoyed being able. Yeah. am I back?
Yes, you're back.
Yeah, you're back.
Yeah. So he didn't lie to her, but then a few days passed, and then he was able to bring up the topic and ask and to approach it that way. So
you need to be in that mental space where you're prepared for whatever is going to come, and understand that, again, it's not malicious. You have to presume positive intent. The reason, I mean, as a leader, the reason that I come to you to say we can be better is not because I want to beat you up and make you feel bad. I'm trying to motivate you to say, look, that was good. If we make this change, then things are going to be that much better. And let's try that and experiment. I mean, this is what DevOps is all about.
There's for folks who are interested in that kind of space, there's if you read Hastings' book about Netflix, there's a lot of very, very interesting stuff in there about the culture of candid feedback that kind of drives high performance at Netflix. So that's.
But it has to be culture. That's a cultural change. Everyone's like, "Hey, it's coming."
Yeah, that's absolutely a core part of, and both ways. I mean, I would also add to that discussion that, you know, if you present as a leader, as someone who welcomes feedback yourself, then that promotes a space in which people feel that feedback is safe.
And it's about being vulnerable. So when I ran teams, I was forthright to say, look, I know that wasn't great. I need your help. Yeah. When you ask for help. So that's another key is if you are the one asking for that feedback and saying, look, I understand that wasn't great. How could I have done it differently? How could I have done it better? And be vulnerable to the fact that you're not perfect. You didn't do it the right way, and that you're ready to learn. People see that and respond to it.
Well, I think we could talk about that topic all day. It's certainly something that's super interesting to me, but we do have a conference to get on with. So thank you very much, Pete. I enjoyed that talk tremendously. Thank you for joining us, for getting up early, and hopefully you'll stick around and see some more of the great content that we've got coming up. On that note, hopefully our behind the scenes folks will bring our next speaker in. There we go. Fantastic. Hello, Rotem.
Hello, how are you?
That's a great flag you've got in the background there.
Thanks. It's from my last DevCon. I spoke over there a bit.
Fantastic. So our next speaker, Rotem Bar, is head of marketplace integrations at Cybersecurity, and you're going to be talking to us about package managers and security, Rotem. So we'll keep the show on the road, and I'll pass straight over to you. And the floor is yours.
Great. So I'm Rotem, and I'm going to talk about package managers. And part of what I do, actually, I'm a cyber paladin, already 20 years now. And I'm building a marketplace, an application security marketplace at Cybersecurity. Cybersecurity is helping organizations all over the world protect their CI/CD pipelines. And because I'm building and looking at all the different attacks that were in the passive and the software supply chains, I decided to talk a bit about package managers, about what you can trust and what you cannot trust in these different package managers. So I'm going to focus on a few, and I will give a lot of examples, and I hope you will enjoy. I do a lot of bug bounty in Israel. So there's a bug bounty Israel group I'm organizing. Once a month we have some meetups, and I'm just hacking and building stuff since 2002, since the army, and all over the place, automotive companies, satellites, production plants, banks, whatever you want. I help protect them and less hacking into them, but this is a part of what I do. But today I will talk about package managers. So if you go to Wikipedia and you try to look what is a package manager, it's actually a program that wants to install, upgrade, and configure and remove programs from the computer. But most importantly, it does it in a consistent manner. That means that if you want to install something, it will install every time the same package that you want, and you won't have any surprises. And this is now, in my presentation, I will show you where it goes good and where it goes bad in different areas in these package managers. So back in the old days, I was downloading lots of stuff, and I used the get right because I wanted to download it all night and then disconnect from the internet. Now nobody disconnects from the internet, but then you had to have different programs that help you manage your downloads. But today we have much more interesting and more easier ways to install, and you can just like say, I want to have a package like called Dragons. I just pip install Dragons, and it magically appears inside my computer. It magically, all the versions, everything happens. And even I'm so lazy, and today we are very lazy, so we even can just clone a repo or have a different project we want to install, do npm install or pip install or whatever install, and it just knows from a configuration file exactly what I wanted to install, installed it. I don't even know why it installed it, how it installed, and it's kind of black magic from this area today. So we are having lots of trust in the package managers themselves to install whatever they want to install. But we are talking a lot about package managers, and I want to talk a bit about what is a package. So a package can be a lot of stuff. It can be a very large package that has years of changes and lots of people working on it, and it can be something like isNumber. I gave an example over here. isNumber is an NPM package. It has 250 million downloads per month. It has 4 gigabyte downloads. I don't know what's a gigabyte download in GitHub, but it's a gigabyte download. I think it should be milliard. But it had like so many downloads. And basically, if you look at the code, this is the code. It just does like, I think 7-8 lines of code, and that's it. And it was maintained. It was last updated, I think, 5 years ago, if I'm not mistaken. And if you can see there's an OpenSSF scorecard program that goes over the most common packages and sees what's their scores, and they have different categories. And you can see it wasn't maintained. It doesn't have code reviews. It doesn't have best practices. It does have a license, and that does have different stuff. So it got a 4.8 score, and everybody uses it. You have 250 million downloads a month. And the big question over here is, what will happen if someone one day will change this package? A maintainer can go and add this 2 lines of code, and you know that hack system just is something that is very bad, and you don't want it to be happening on your computer. And the moment he will update it, it will start new packages and new programs that want to download this specific package, will download the new code and will run it inside their development computers, inside the CI/CD, inside different areas. And the question is, who can change this package? So we have the maintainer itself. Now we have like colors and faker, and there are a lot of now, because of different politics and war stuff, people just say, yeah, I'm maintaining this package. I'm the maintainer. I can change it. I will add this code to the package and just ruin it for everybody. And sometimes the people just like pull the plug on the package, or they change something, or they do other stuff. And the thing is, it starts breaking, or even can hack into different areas. The other way is hackers. If I have, let's say we have the UI parcel.js or core or RC, these packages were hacked. Someone got the password of the maintainer. It's very easy to find the email of the maintainer and then find his password. Or in other ways like phishing attacks and stuff like that, they can hack the account of the maintainer, and then again inject code and have fun with the packages. The third thing is confusion attacks. Alex Bilson showed us, I think last year or 2 years ago, dependency confusion attacks, the way that if you have private repositories and public repositories, and you update something in the public repository, which is private, the package managers get confused and can download by mistake something from the public repository instead from the private one. This was a very interesting attack, and he was able to hack lots of companies and lots of different areas. So the question is, why is this happening? And this is happening because we are all lazy, and we don't want to have fixed versions. And in the dependencies, like all the package managers have different areas of supporting this. In the package, I can say, I don't want 1.21, but I want every time it will be upgraded automatically to upgrade my package. So I won't need to have different types of development and adding and checking and verifying. I trust the package to be that everything will be okay. This is why we have this carrot that says you can upgrade any minor and patch version in the semantic version over here. To fight these problems and to find a way that we can create reproducible builds and have to know exactly what we want, so we created log files. And log files mean, I know you wanted to have 1.21, but actually when the developer tested and the pipeline tested in the testing area and in the developer machine, actually what he checked what was the 1.4.8 version. And actually the version had this integrity, this SHA-512 integrity, and this is what was downloaded. So anybody in the future that wants to download this version should go to the log file and should not download anything else. If you download anything else, please stop downloading, installing, and check what was the difference. And this means that now developers need to update the log files, additionally to update the JSON files, let's say in NPM. But then my question here is, what can go wrong? And this goes into a research I've done, and lots of other people also done in the internet this past year, and even further back, about package managers. And if you can, this is not a live show, so I don't have, I cannot ask the crowd over here, but if you look at this Docker file, and you probably can see a few problems. I will go and show you the different problems that I found. Maybe you can find more. But the Docker file, if you use the latest Docker file, every time you will upgrade, it will upgrade every time someone will push a new tag into the Docker hub, for instance, or ECR or whatever, it will download the latest version and not from a specific tag or even a specific hash that we wanted to use. The other thing is, over here you didn't see in the pack, we added only the package JSON by mistake to the Docker file, and now we didn't copy the log file into it. So what happened is, inside the Docker file, it didn't know which versions were locked, and it guessed and went to the internet and went to the latest copies and downloaded the new versions with the malware, virus, whatever we had over there. The other thing is, if you go to the left, you have npm npm install does actually npm install updates the log file, and it tries to go and find what are the locked versions, but if it doesn't find, it doesn't force you to use the locked versions. npm CI, what it's supposed to do is validate the locked file and validate it's only the locked version that in the package lock. And this happens in all languages, not only in NPM, but I'm focusing on NPM because actually they had many problems in the last year, and it's a good research ground. So I went, for instance, into Amazon in the past, and when I was creating a new Lambda function, I saw the Docker file had the same problem. They copy package JSON, and they didn't copy the log files. And this means that this was the default template for Lambda functions, and everybody that uses the default template were vulnerable. So I contacted the AWS and we fixed it. And now every time they added the asterisk, so it will also copy the log files. But also there's a recommendation to run npm CI -minus production because it's much more secure running npm CI, not npm install. npm install doesn't verify the log file itself. So in production, we always recommend to use the log files. And this is one thing I want you to learn from and see from this presentation. Use the log files. Don't delete them. Don't disregard them. You make sure you use them, even if they're there and if they're not there. It's very important for the health of the CI/CD environment. So using npm CI, let's say we installed Axios with a specific version, and they have this package lock file. And when I do npm CI, because it found 0.21.4, npm CI should always install the 21.4 version. And this is happening, this is how it should behave, and this is how it behaves in npm 6. If you can see, when we changed it in the package JSON, I was lazy. I went to the GitHub, changed it to .1, did npm CI, and it failed. It failed the build. And then it couldn't continue until we changed it back or update the package lock file. The thing is, I investigated npm 7 and in the start of the year npm 8 also, and I found out that when I do the same thing with npm 7, nothing happened. Like it say, yeah, okay, it's great, you changed it, so maybe I'll just install the version you wanted to do it. So it didn't look at the log file at all. And actually, because there was a change in the package JSON and it didn't find it in the log file, it went and downloaded a different version, a 22 version, because the 22 version was the latest. So it was kind of a mind-blowing event for me. I saw that CI doesn't really work. And this I went to the internet, and then I saw, actually, before I went to the internet, I did another game. If I created an empty log file with only an empty JSON, it just worked. It added everything. So if you want to bypass all protections, you can create a package lock with an empty JSON file that continues without asking questions. Unfortunately, we fixed it after 1 year, like NPM fixed it. I went to the GitHub and I went to the issues and saw someone say, yeah, last year NPM succeeds when package lock doesn't match. So I tried to understand. We opened a CV for it. I think the CV got a critical base score, but I don't know if it's that. I would give it a 7 point something, another 9.8. Still, it's not shell shock, but it's really interesting to see that this was getting serious, and after a while they fixed it. GitHub went and fixed this problem, and now in the latest NPM version, I think 8.1.4 and above, it doesn't happen anymore. But if you go to NPM and look into the issues, you see there are other issues. When you use overrides, it doesn't work correctly. When you use the integrity is sometimes not repaired automatically by NPM and not noticed. So there are still different problems, and I think one thing we need to learn about this, that the packages themselves and the package managers are there to help you download the files, but you cannot trust them entirely not to have bugs in them and not to have they're constantly trying to improve, but you should verify yourself all the packages and verify yourself that the integrity is properly, and before you download and after you download, you need to make sure, because the package managers, some will do it for you, some will not, some will say they do and will not do it correctly or not understand. And this is a game that we need to understand and play until we have like a proper RFC or way to verify that what you wanted to download was really downloaded, and that's it. And I don't know if there's a standard today for downloading packages. And this gives me to another bug that I found last year, and this is actually, I spoke on DevCon, last year about a different malicious code analysis. And I was investigating scanners and security scanners and how I can make them execute code. So if I'm a hacker, how can I attack the scanners that are scanning my code? And I found out that the same problem happens also in NPM. So I'm saying NPM, but it also happens in different package managers. So I will show you this soon. But if we go into NPM and I want to find a way to run it safely without running any scripts, without running any code that can happen from the package JSON, from the different areas of the repository, I just want to install, to download the packages and do nothing with them. And this is why we have npm CI -1 signal scripts. We can download the files, and all the pre-install, post-install, all the scripts, they shouldn't work. And this is a good practice, because sometimes when we use package managers, we have credentials to our repository and other different credentials to push stuff to CD, and we don't want to mix the different environments. So I want them not to run any script. So for instance, if I want to have a secure way, I have an npm token, I run it with -1 signal scripts, and then unset the npm token and run my post-install scripts. So, and this way I'm more secure, and they don't have any way of a leakage of the npm token. The thing is that npm does look for .npmlc files, and this is by definition. And these .npmlc have instructions of what npm should do. So if you go and you put, let's say, a .npmlc inside your repo, then when npm will run, it will look for, let's say, npm 6 looks for unload script. And in this unload script, I can inject a JavaScript script inside my environment, inside my own repo that will execute. And this is a way to bypass the -1 signal scripts. Actually, it's not really bypassing it, because ignore scripts was never intended into not running scripts in different ways. It was only intended to not run scripts in the post-install and pre-install and all the lifecycle, the script lifecycle. So it's a bit confusing, and there is no real way to prevent npm to run it. In npm 7 and 8, they fixed it, and there's no unload script anymore, but you can just replace the git shell file with evil git, and then happen the same. It will just like create the same option. The thing is, over here, you will need to create another npm package that gets from a git repository instead from the unstore npm. So the attack scenario is pretty interesting. A developer can add a .npmlc file, push it into his repository, even it's a local repository. If it goes through different scanners or different the Jenkins, the CI build files, the CI build pipelines can go and run and execute npm, and then you can run CI script, steal the CI secrets, have production access, network access. It is part of Jenkins is also a code execution as a service platform, but you never intended to become from the package JSON itself or from different areas over here. But this also happens in Python. If, for instance, someone has a pip install, and pip install is looking for setup py and setup cfg, then setup py is Python. You can just like put whatever code you want over there, and it will just work. It's by definition importing Python and running Python. So you don't have anything really to do about here. There is like verifying in the setup CFG, it's much more hard, but setup CFG now usually is invoked by setup py. I think in the future, like there's changes now that you can run it without, but it's still not mature enough. Again, with requirements.txt. So you have a different way to install requirements.txt in a pip. You can just like say, give a list of requirements. And over here in the requirements file, Usually it's line by line, but you can have special flags. The -R flag tells access another requirements file from a different source. You can put a file like etc passwd and get the log files, the passwd into the log files, or you can just like access the local network by HTTP and have a SSRF target and start attacking in resources inside the area of the network. So it's pretty cool to how to abuse all this functionality. The same goes for Ruby. It's just the gem file is just Ruby file that is executed. So the same thing happens. And this is like, by definition, package managers will execute code. And we need to understand this, and we need to understand that this is what they do and put the proper protections around it too. So when we execute something and we know it has access to different artifact repositories, it has access to secrets, it has access to the environment variables, it will have access to everything. And someone with enough intent will be able to execute code over there, even if it's a static configuration file that doesn't allow you to execute code. I think the last thing I want to talk about is auditing. And if we see auditing, so we have lots of security auditing and we have lots of tools, but also NPM gives us out of the box security auditing for vulnerabilities. And this is usually I just like install a package, I do NPM audit, or just even by default when I install, it tells me how many vulnerabilities you have inside the package. And it's very reassuring that to know, okay, there's a critical vulnerability, I will update it. So I'm going into, when I'm installing like Pack Resolver 4.2.0, and I know there's a high severity vulnerability, then NPM will just tell me there's a one high severity vulnerability, you should fix it. Maybe 4.2.1 will be fixed, or they go to the latest version, and then we should have a proper way to fix vulnerabilities. Don't just not use log files and then they will do latest all the time, because we will have the problems from this start. So we need to make sure we have log files, we need to make sure we have these vulnerabilities, and when there's a vulnerability, act upon it, install, upgrade the vulnerability, upgrade the package, and test it before just automatic testing viruses, new viruses. But what I understood and I found out in NPM version 6, when you give an alias to a package, then it won't validate the package. So if I gave like Pack Resolver the same alias exactly as Pack Resolver, so it does nothing for the code and it actually works as intended, but NPM audit or even other package scanning solutions will not see this alias and will be fooled by the syntax. I don't know why it really happens, but it will find 0 vulnerabilities. They actually fixed it in the version, in the latest in NPM 7 and NPM 8. And then you can see there are different ways to bypass this. So if we go to out of store package, let's say github.com, I go to the GitHub repository itself, still NPM does some magic and goes and tries to resolve the Pack Resolver, and it knows the GitHub and it goes and find that this has a vulnerability. That's pretty cool that it was succeeded in doing it. But when I'm going into, and I try to play with the syntax a bit and find out how to bypass it. So if I go and download it from a specific Git and I added a dot after the github.com, then I successfully bypassed the protection or like the mapping that NPM did, and was able to download without any audit. And this means that if I'm a package maintainer or I have some code, I can add this piece of code, and the audit will not find it. It will not find any vulnerability inside it, which means that also the security team will not know about. It will not know that there's a vulnerability, but it will not know also that the package manager skipped this vulnerability. So like I asked them, and we talked about in the RFC a bit, I talked with the NPM team to check if we can add an RFC, another, like, not found zero vulnerabilities, but how many packages were skipped in the process of testing it, because we have this package that is skipped and it didn't succeed in validating the and checking if it's vulnerable or not. Because dependencies are recursive, then you have a problem that even if you have this awesome project and you have a dependency, but this dependency has an out of store dependency that you weren't aware of, you will still see zero vulnerabilities, and you don't even know that it did some kind of cheating and bypassing the whole protection of in the future. And this is a good way to add in malware or add in versions that in the future you can just update it and it will automatically update. So it's a good way, and it's too bad that we don't validate our own vulnerabilities. And this is something that I want also to think about, that you should always, even that you have inside these package managers, you have SBOM and software bill of materials, and you have vulnerability analysis, and you have all the tools, you should trust them that they want to do their job, but they don't do the more advanced testing. And you should have a mature solution that creates proper SBOM, creates proper vulnerability analysis, creates proper testing, and most importantly, that you know when it fails, when it doesn't do. So you need to know that it does be able to get the vulnerabilities, but also that it failed is for some reasons or somewhere. We had actually last week, there was a bit of talking about the NPM package maintainers, and someone just filed and created a tool that to check unregistered domains. So if we have a maintainer that is a maintainer for a very known package, but his domain got expired, someone can just buy the domain and then reset the password into his account. So this is something that happened, and then we saw lots of people starting to scan all the packages and found 11,000 hijackable packages, and there was a lot of noise in the last 2 weeks, I think. And just you should know, you cannot fully trust the maintainers because they created a package. Sometimes they forgot about it. Sometimes they didn't continue. They are people. They are hackable also. They have domains that are hackable and DNS, and it's the whole game. And it's very hard to protect everything over here. So your next task is to find all applications in your organizations that the maintainers don't have an email, that don't have a domain, or the domain expired. And this is very hard to do. Nobody is really doing it, and if you will do it, you will see how much problems you have inside all of the packages. So a quick recap: package managers install what they want. They execute unwanted scripts. The audit checks are easily bypassed, and just random people maintain packages, and everybody uses them. But we rely on open source. We cannot live without package managers. If you will tell a developer now not to use any package manager, it will be a problem for them. It's part of our day-to-day life. I use it every day, but we need to know how to protect ourselves. So we need to make sure we use log files to verify the log files are in use, to manage our correct software bill of materials database, and to monitor for every package download that is not in my software bill of materials. I want to make sure that package managers don't have any permissions. Put them in a container, put this container in a box, put it in another sandbox, give them as much minimum permissions as possible, monitor what they do, treat them as viruses or with least permission, and just don't let them do anything. I know they need the internet access, so from other checks, just like run other checks with external checks with external tools. Make sure you're taking into account also the specification file itself and also the log files. If you have a log file, sometimes it will be lost in the way. Sometimes you will have differences, a drift between the specification file and the log file. What will happen? You cannot rely that the package manager will always use only the log file or use the specification file, or maybe a developer will remove it and delete it. At the end, the most important thing you can do is make sure that in the binary and the container itself, you have the same packages that were supposed to be in the log file and supposed to be in the specification file. And this is the way to validate that everything is true and nothing drift and nothing moved into production. And if you have out of store packages, just verify them manually. I would just say everything that is not inside the package manager repositories, you have to verify manually. You have to check it, to test it, and if there's a change, I don't know, sign it and make sure that everything is valid over there. Any questions? I don't know how much time we have.
Thanks, Rotem. I think we've got a minute or two, so we'll take a couple of questions. I think Andy had one for you.
Oh.
Hi, thanks for the talk. That was really fabulous. That domain hijack you were talking about at the end, there's lots of things that we can do there, and it looks like a lot of the problems that you demonstrated there were to do with malicious updates to maybe an untrusted developer or something like this. Do you think there's a space for code signing in the package registry? I was
sorry. Yeah, I see people. First of all, yes, I think like code signing is everybody's talking about it, and it's the next thing that people want to start to do. It's a code signing from code signing commits and the code signing even different areas inside the package itself. You see, we have integrity, but it's not enough. And the more we have ways that we can sign different areas, if I can sign the code and then sign the container and sign everything else and validate everything inside the container and inside the build systems, so validate everything inside of the different steps in the way, it will be much more easier. The thing is, when you validate something, when you sign something, you need to make sure you have the proper solutions and the proper security controls, that you not just sign on blindly. You need to verify it and then sign it. So if someone adds a very execution code, so maybe do some static analysis, and then after doing static analysis, sign it automatically. But yes.
Okay, and one more question. Are there any statistics of the prevalence of attempts of attacks within the most popular package managers?
This is hard. Actually, I didn't play with statistics. I'm more on the defending side and looking at different, from the overall view and trying to find the problems of the future. I don't do too much incident response, so I don't know of statistics, but we do see that in the past, we had, because of CodeCov, for instance, a lot of shells started popping up around the world. Monday had in their IPO risk that they were hacked and their whole code base could have been stolen. So we do have different risks over there, but because every company, because it happens inside the companies themselves, and it's not like public information, I don't think we will ever have proper statistics.
Okay, that makes sense. Great. Thank you very much, Rotem. Excellent talk. Thank you. So we have our next guest ready now. Joni Clippert is the founder and CEO of StackHawk, following on from external threats in log files and package managers. So StackHawk is an application security SaaS startup built to help developers find and fix security vulnerabilities in their code. So thank you, Joni. The floor is yours.
Oh, thank you so much for having me. Happy to be here today. me grab my notes. Awesome. Thank you so much. As was introduced, my name is Joni Klippert. I am the CEO and founder of StackHawk. I have been building software for software developers since I graduated from my MBA program in 2010. And in 2019, I founded StackHawk to bring application security to the DevOps workflow by helping software developers find and fix security bugs in their code before they deploy to prod. My co-founders and I saw an incredible opportunity to reimagine application security through a software engineering lens. So in this talk, I'm going to share what key DevOps tenets have been sort of missing so far in the realm of application security that have somewhat hindered AppSec from shifting left into the developer workflow, and what we need to do to modernize the practice and rapidly deliver more secure software. So DevOps is pervasive and it works. And what I mean by this is that DevOps has unlocked the ability for companies to deliver value to their customers faster. So over time, we've seen pretty major shifts in tooling and processes that help us do just that. And that is develop software quicker, get features into the hands of our customers faster. So Agile, unlock the ability to quickly plan, develop and deliver software more rapidly. Virtualization, cloud, and infrastructure as code removed that sysadmin bottleneck as we really empowered engineers to deploy and manage their resources. And then we saw massive efficiencies with automation throughout the integration and deployment pipeline, and then further unlocked speed with orienting to very small releases, breaking up the monolith, and investing in microservices architecture and containerization. And then we really improved our uptime by creating the ability for software engineers who wrote the code to then manage that code in production. So the next sort of most important area of investment is to empower our engineering teams when it comes to AppSec. And when we do this, we unlock the ability to not only deliver software quickly, but more secure software quickly. So whether you're part of a younger company born with the technical and cultural tenets of DevOps, or part of a legacy enterprise that's undergoing digital transformation, we invest in these principles to quickly respond to customer needs, deliver high quality software, and ultimately remain competitive as a business. So why hasn't AppSec followed the rest of sort of the product and engineering organization in shifting left? As I was doing research for StackHawk, I wanted to understand why security hadn't yet made it into the developer workflow. I interviewed more than 50 CISOs and security professionals, CTOs, VPEs across the entire stack. And in a matter of weeks, I found that we both had some cultural barriers and some technical barriers to current solutions, as well as some pretty, as I mentioned, meaningful cultural barriers. So the most glaring thing that stood out to me was that the relationship between security and engineering was pretty deeply strained. It wasn't too dissimilar from early days of sort of your traditional IT ops versus dev, and it was maybe a little worse, honestly. These teams have very different KPIs and operational objectives. So whereas your engineering teams and development teams care about focusing on business objectives, security teams are aligned to reducing risk, oftentimes in a way that can come across to the engineering team as at the expense of the business objective. And it fosters some kind of interesting cultural issues. So you'd hear a lot of kind of lack of trust and empathy, things like you'd talk to security folks about engineering being more involved in AppSec, and I'd hear, oh, you can't get software engineers to care about security, to which I totally call BS. From engineering, I'd hear things like the security department being the department of no, or difficult to work with. The next is a really important tenet of DevOps, which is transparency and observability. And that was something that was missing in the security discipline today and a lot of the tooling decisions that are made. So developers commonly don't operate in security software. This is changing, which is good. There's a little trust that developers should be able to see or action on issues unless a security person tells them to, which is really inefficient since the engineer is responsible for fixing the issue anyway. And then lastly is a topic of empowerment. So my co-founder, Scott Gerlach, was formerly the CISO of SendGrid, and he would talk about how we want developers to care about security, but we don't always trust them to take a first pass at assessment and resolution of issues. So he comments on this tendency for security teams to buy AppSec software and then lock it down so tight with approval gates everywhere, it's impossible for software engineers to use. And then if you set aside the cultural things, there are a lot of technical challenges that I think companies face when trying to modernize AppSec. First thing is most tools in the market were built to run against production by the security team. And there are several issues with the production bias, and I'm going to double click on this in just a minute here. Second, a lot of the tooling is really hard to configure and deploy. Many, especially in the land of DAST, which is where StackHawk operates, which is testing the running application, it can be difficult to get those capabilities working in a repeatable manner, and making automation really difficult because a lot of the tools just weren't built for it. And most AppSec tools were built with the idea that a human would manually run tests against an application. And again, this is starting to change, which is really good. Third, a lot of these tools generate a lot of noise. So the output is super verbose and it's written in a very like security person language versus something that's really easy for a software engineer to quickly grok it and action on it. And we all know that a key component to DevOps tooling is to really mitigate noise and ensure that a software engineer's attention is really only drawn to what is important so that they can keep moving on and delivering business value. And lastly, there's a lot of conflict with some of how these tools were built, and those tools running in a more modern developer tooling and processes system. So on the previous slide, we talked about security folks saying, okay, devs don't care about security, but with this list of challenges, it's like, how can they afford to care about it? It's really expensive to care. So we're going to talk about some ways that we can change this. So in a world where software engineers are largely measured by delivering business value, the cost of caring can be too high. And then we're going to talk about how to lower that cost of care. So we discussed that a lot of AppSec tools in the market are built to run against code that's already been deployed to prod, and they're designed to be operated by a security professional. This orientation toward production and lack of involvement by the development team at the right time with the right context makes it impossible to modernize AppSec. Please excuse me. So AppSec tools, as we just talked about, are commonly run in prod by either the security team, because prod is where they know the app the best, or by a pen tester, because that's their point of access. In this context, it makes sense that these tools to date have been designed for these groups. However, it's highly inefficient. Both groups struggle to instrument their tests because they're less familiar with how the application works. So setting up an engagement can be a pretty heavy lift to get a really good assessment. From there, the primary value, because that lift was so heavy just to get the technology running, these teams can really value the finding of things. So the number of things found versus finding and fixing the right things are the most important things. So the things we don't want to focus on is just like the number of issues that are found. And this can be really inefficient because the finders aren't the fixers. It happens way too late in the process. And when a team breaks someone's stuff, oh, look, I found all these security bugs 6 months after you deployed this to production, it kind of fosters that adversarial relationship. So I'm not advocating that people shouldn't get pen tests or that the security team shouldn't even be involved. That's not what I'm advocating for. I'm just suggesting that the production environment is not the first place that we should be finding out about this kind of information for our applications. The next most critical part of the production bias is timing. So as companies are rapidly, more and more frequently, like many times a day, shipping code to prod, if security is not baked into this workflow, what we find is either you're not rapidly shipping code, in which case AppSec is processes act as a barrier to shipping code, or the security team is constantly playing catch up. And that's what we actually find is to be the most common thing, is that folks don't really feel like they have control or knowledge of the security of the code that they've put into production. So it gets worse. This always kind of makes me giggle, but it shouldn't. When AppSec tools favor running in production, like obviously the bugs are already in prod. So there will be a lot of times where we intentionally ship bugs to production, but the intentionality is the important thing here. So it should be done with eyes wide open, and it should be a risk-based decision. So you might know that exposure is super limited and that issue will be fixed in the next sprint. That's great. But production is not the place that you should be finding if there are any security bugs. The next part of the production bias is context. So a check for security bugs in prod, like X period of time after it's been released, is inefficient. So engineers have moved on to other sprint tasks. They're no longer in the context of their code, and fixing involves context switching, which can be very expensive. So when scanning for bugs in production, typically tools are scanning an FQDN like www or app. And the result can be, especially with DAST, a really long list of bugs that exist somewhere in the application. And that makes it really difficult to identify the app or the service that's affected. And it lacks the context of the specific data that's handled by that service. So you end up with a lot of like ticket shuffling, trying to identify the service that was affected, trying to identify the team who owns that service, and then trying to work those issues into the sprint. So when we talked about an inherent focus on the number of bugs found, and then the percentage fixed over time as being a primary driver of value, it also totally ignores the business context of the findings and trade-off decisions around business value generation. So instead, we really need to be engaging in discussions like, how important is this application or service to the business? Should we be fixing all of the bugs on an internal application or just going fast on that? And how should we think about our apps and the data that they handle? So the production bias results in the wrong team. And what I mean by that is the team that isn't ultimately going to fix the bug, finding vulnerabilities at the wrong time because they're in production and without appropriate context of the app or the service that is how that runs, the data it handles, and what it means to the business. So this is how security-based development works and should work. And I'm just going to read the slide because it's poignant. So when a team writes code, they know that the syntax because it won't compile. When a team merges code, they know that there's a problem when it doesn't merge. When a development team runs unit tests, they know the code is wrong when it fails the unit test. And when a team runs integration tests, they know the code is wrong if it doesn't work as it's designed. And when a team introduces a vulnerability, they should know right away because it should fail a security test in pipeline, just like the rest of the checks and tests we put into our code base. So at this point, I super want to emphasize that instrumenting test-driven security is something that engineering teams can and should do. So even if they don't yet have a security team or function at their company, it's something that an engineering team can totally run with, just like they do the rest of their tests. So let's talk about getting it right. So what does the right team look like when it comes to AppSec? It's developers and informed stakeholders. Developers fix security issues, so let's make them aware of those issues as they're writing code. And in this world, we're reimagining the role of security as a coach whose responsibility is to enable the team to be successful. So there's a ton of value in optimizing for the developer experience, right? It's super efficient because engineers are able to find and fix issues in flight. It democratizes security information across the organization. Security becomes a standard discussion while we're building software. It affords collaboration among teams at the right level and provides an opportunity for targeted education. And then the security team is able to scale. We all know that we cannot scale our security practices with humans. We have to do it with automation, and we have to do it with our software engineering teams. So as a pro tip, it's like absolutely leverage pen testers for security reviews, tough business logic findings, but not as a primary point of access to your security posture. Now let's talk about the right time. So the right time to be checking for AppSec bugs is pre-production. We should be instrumenting our security tests in CI/CD to give engineers feedback immediately on the different services and applications that they're working on. So many of our customers are checking for AppSec bugs on every PR or merge. And this is ideal because if a security test fails, you know you introduced a security bug in your latest change. And then when we add the ability to test locally, engineers can really tighten and quickly iterate on that fixed test loop if a new bug is identified. So for AppSec to modernize, engineers need to be able to test while writing code and test while they're building code. And our security teams or tools need to play really well in these phases of development. So the next piece is getting the right context. So the right context for security bugs in your code is as you're writing it. And when this happens, engineers can fix really egregious security issues in flight. And that's going to result in less bugs making it to production and less rework later. Next is in context of the application itself. So the most important piece of context that comes through with real-time security testing is the context for the engineer of the application that they're working on. So teams can leverage their microservices architecture to instrument security checks on smaller bits of code, which make it easier to isolate and fix those security issues. So teams should also be able to make better judgment calls when they know the job of the app that they're testing and the kind of data that it handles. And then the third piece of context to get right is business context. So we have to empower software engineers to fix the most important things, not all of the things, while they're in context of their code. And the security team really should be collaborating with engineering on assessing business risk and working across product and engineering to triage sort of those lesser severity issues based on resources, business objectives, and risk. So when the right people are doing the right jobs, there is a bridge built between security and development. The goal of the security team becomes enabling the business to go faster, safer, and they lay the right foundations to focus on scaling that security organization within their company by empowering software engineers and helping to serve as educators around risk. When this happens, the development org can build more secure software faster. We talked about that. And when we automate the job of finding AppSec bugs, we empower software engineers to fix those issues in flight, and security becomes a very natural part of the software development process. So that was all very theory and high level, and I wanted to show you a quick diagram of how a modern security workflow can work. So this is how leading teams can introduce instrument security and CI/CD. Next, we're going to talk about a bunch of different tooling to get started with. But as you are sort of checking in code, it compiles and builds. At that point, just in the same point that your unit tests are running, your integration tests are running, this is where your security tests should be running. And then building tools and pipelines that allow you to have some optionality here. One, you can run it async. Two, you can run it in pipeline, which means that if the security test passes, it gets packaged, it gets deployed, and goes through its natural process. If a security test fails, you have the option to break a build, go through finding details, recreate the issue, and then further triage that by either fixing it, creating it, or creating a JIRA ticket, and then re-merging that code back into your pipeline. So that is how sort of a more modern way of doing application security testing works. So I know at DevSecCon, there is a variety of backgrounds. So you might be thinking, okay, that's awesome. I don't know where to start. So if you're a software developer, I'd start thinking about security testing, just like you would integration testing or unit testing, and as part of a required software delivery pipeline that the engineering org owns and instruments. From there, I've included a couple great types of AppSec tools that every company should be using. So we've got SCA, or software composition analysis, that really helps teams identify vulnerabilities in open source libraries or containers. These tools compare versions of libraries or third-party components that you're using to known vulns, and an alert, alerts users when it's time to update. Next is DAS. That's the world that we live in. So dynamic application security testing, which scans your running apps and APIs for vulnerabilities. It's an active scanner that can sort of simulate an attack on your app with inputs, seeking outputs that indicate a present vulnerability. So the nice thing about DAST is, since it reports successful attacks, there are less false positives. So to get started, if you're a software engineer, you can skip step 1 on this slide because you know your app, and simply choose an app or service and start scanning for AppSec bugs. Choose the technology and just start scanning in pipeline. And as you get comfortable, you can layer in additional applications and technologies that provide a more robust security posture. So that is it for me. Feel free to email me at joni@stackhawk.com or visit StackHawk to learn more about how we're putting AppSec in the hands of software engineers. And I hope you enjoy the rest of the conference.
Thank you, Joni. We do have a couple of questions. The first is, so how can developers watching this talk convince their management of the importance of that baked-in security?
You know, that's a great question. I think as somebody who has managed software engineering teams in more of a product capacity before my CEO hat was put on, is the disruption and the cost of unplanned work is really, really hard on an organization, because we're making a lot of promises with roadmap to our customers and to our business constituents. And when you get a bunch of vulnerabilities dumped in your lap to disrupt a sprint, it is very expensive for engineers to context switch to fixing something, maybe code that they haven't seen or touched for 6 months. So that's a very meaningful cost to the business, because we're switching context and we're not working on business value anymore. And then 2, this is not the first thing that we lean on, but if you're waiting to assess risk until production, you're instrumenting risk into your business. And so I would encourage folks to not do that, especially if it can be automated as part of just actual traditional software delivery.
Great, thank you. And Catherine asks, do you have any recommendations for the catch-up portion? So the example that she gave was running an SCA tool that detected lots of vulnerabilities and generating so much feedback that the team then doesn't know how to prioritize which things they should fix.
Yeah, that's another great question. So, you know, we spend a lot of time in the realm of DAST, and as we onboard our customers, a very important place to start. So they'll start running security tests on a certain application. And we're like, you've got to baseline that app. So sit down with your team and make sure that you've triaged everything. It's like either, you know, fix the most egregious issues, make tickets if those are things that you want to fix with additional resources later, or sometimes in tools you'll find false positives or things you're going to risk accept. And it's really important to do that baselining, because when you're running it in pipeline, if something net new pops up, it's like, I have to pay attention to this and I have to fix this issue. Another thing, not to be pitchy, but to help engineers focus on the right things, we just released an integration with Sneak Code, so the SAST product. So what's really great about that is SAST can find a whole lot of issues that may or may not be accessible to the internet. And DAST shows we were actually able to successfully attack this. It is accessible to the internet and it is vulnerable. And by correlating those findings, yes, it was accessible from the internet. Here's the line of code that you need to go fix. That helps a software engineer know exactly what to do while they're in context of their code and eliminates a lot of that noise. Our market and our tooling across all of them have a lot more work to do here to make sure that it is not a disruptive process for software engineers and to fix things. But I think the leading companies get it. We're aware of the problem and our best people are on it. And we're working on fixing that for software engineers.
I mean, I think that's the kind of next stage of this problem, really, isn't it? Is being able to actually say, I mean, obviously, I hold my hands up that I work for Snyk, so this is a familiar space for me. But you know, where you know, is that code path actually being executed, or you know, in the context of you know, of cloud deployments, can I actually get to that? You know, and it's being able to, and I think as an industry, we're all starting to get on that road, but it's taken a very long time to be able to have the data and the you know the frameworks to be able to make those connections, you know, to say, and you know, it's taken infrastructure as code and all the rest of it so that we can actually say this is how something is in reality in production right now before we can start making those kind of calls. We have one more question from Kevin Joni, who says, how do I create a security awareness program for developers to ensure best practices in the SDLC and not engage in war with DevOps? I'm not sure who Kevin works for, but
well, listen, engineers really care about the quality of their code. There's a lot of pride associated with delivering great code to customers, and it includes security, right? I think to not engage in a war is to not let perfect be the enemy of good. Get tools that run in their processes, in their systems. You cannot take, so Dast, like a legacy problem with Dast, is it could take like days to run. You can't run that in pipeline. So you have to find tools, I don't know, like ours, that run very, very quickly, and they're not in their way, right? It fits in their tooling, you know, UIs and IDEs and experiences that say, like, this is the most important thing for you to fix. You can kind of ignore the rest. We'll get to it later. Pay attention here, and then get out of their way. So you got to enable them and get them started on the right things, and then just be a partner. We're seeing it a lot, honestly, that AppSec teams know that in order to scale, they have to have friends in software engineering, and they have to be able to automate a lot of these things. So it's coming. I'm not perfect. I don't have all of the answers, but give them tools they can use, and give them tools that are easy, and empower them and trust them, and you'll build a good relationship.
We did some survey in our cloud application security survey last year, and you know, a huge proportion of developers filling out that survey were clearly deeply cared about security. So, you know, I think some of these old kind of thought patterns of, oh, developers are this way and security folks are that way, you know, are probably not holding as true these days as maybe they were, you know, a decade ago or so.
I agree.
Okay. So have we dealt with all these questions?
There was one more, if you just want to answer this one quickly, Joni. So Yano asks, are there any specific tools that you would recommend to get started with this test-driven security? You can probably think of one, right?
Thanks for the alley-oop. Yeah.
This is a Stack Plant question.
No, I know. I'm like, Bruno, I don't know who you are, but thank you very much. Yes, I highly recommend you check out StackHawk. So what I love about our product is it's language agnostic. So you can, no matter sort of what your application is built in, you can run tests against it. And it also focuses on the API layer, which is super important for modern apps. That's where all the goodies live, is in that communication layer between backend and front end. And you can get started for free. We even have a free product. So if you want to just start playing around and getting to know different technologies, I encourage you to try that out. And then we have great friends at Sneak that have built also great products and have free versions that you can start testing with that also integrate with ours. And so those are really great places to start. And then the other companies have really good tools also. So that last slide, I don't know if you'll be making these slides available, but it has a list of companies and technologies that I think are pretty developer first that folks can check out.
Great, thank you very much, Joni. That was a great talk. I know we really enjoyed it. So we'll let you go at this point.
Thank you so much. Have a great day, everybody.
You too. Right, so it's that point of the day, I think, where everybody now goes and gets coffee, and we have to desperately try and fill 10 minutes of dead air. So we're going to take a 10-minute break here, folks. Well, we won't be taking a break. We're going to be chatting for the next 10 minutes. But if you want to go and grab coffee or whatever, now is the time. The actual content will be back with you at, I'll just grab my schedule. I think it's 2 p.m. UK time. So I'll leave you to do the time zone conversions wherever you are in the world. Right. So I thought that was a great morning, great afternoon, early afternoon session. I'm losing track of time myself. Andy, what was your highlights of this morning's stuff? Oh, with no sound. Okay, we'll come back to you. Jamie, what was your highlights of today's proceedings?
Well, for me, as the least sort of cloud native member of the team, probably Peter's talk, just sort of given some good solid practices there for what developers can do to sort of improve the way that they work and sort of interacting with others, and not just about producing the code, but the sort of sanitization they can run on their own behavior to make sure they're as effective as possible. I mean, I think that message comes through pretty clearly in talks like that, and I guess in Joni's talk as well, that the security problem is at least as much about people and culture as it is about technology, right, Andy?
Yes, I believe I'm audible again. Apologies. Yeah, absolutely. I mean, everything is a socio-technical people problem. Integrating all these very advanced concepts with a team of disparate organizations within an organization, each with their own priorities, especially that traditional barrier between security and development. And yeah, really breaking those down. It's just communication. It's also going out for beers with your colleagues, making sure everyone remembers that we're still people on the other end of screens and all that good stuff.
Yeah, great. Well, we'll come back to that in a second. I know I've got a couple of things that I need to mention. I might even have some slideware here. 1 second. Let's see if this works. Okay. Oh, no.
There were a couple of things in that last talk that really spoke to me while you're...
yeah, you carry on, because I've got some security permissions.
The irony. Yeah, some of those choice terms of phrase. I mean, of course, security-based development is a sensible concept in itself, but that's a really nice framing. I love that. The instrumenting test-driven security. It's when we look at the complexity of all the dependencies that we build into a software application, understanding those attack paths and exploitability is such a major part of targeting the fixes. And when we don't have control of that software, when we're consumers from a sort of supply chain perspective, it's all the more important because the maintainers of those pieces of software are unlikely to be shipping those security tests themselves. And so it's incumbent upon us to do one of two things: either instrument and test our applications in as comprehensive a manner as possible, or what I'm really hoping for in the bright new horizon that I sort of fantasize about in my own head, is actually very large organizations giving back to open source and shipping some of those security tests, bringing their engineers, helping them to become domain experts, and sort of moving the needle for everybody. So
I mean, I think one of the interesting things for me, you know, obviously there's been the OpenSSF is becoming increasingly high profile over the last year or so, and I think that's a fantastic movement that you know, Sneaker also involved in. But you know, the thing that's super interesting, and if you look at a lot of the things that have happened in package ecosystems, it really puts this into sharp relief. Is that the kind of governance and the community around pieces of software becomes almost as important when you're making the choice about which thing to use as whether it's been, you know, just the fact that, you know, 100,000 people are using it and, you know, it passes security tests. Well, yeah, but if it's only got one dude maintaining it, or one lady, or one, you know, maintaining it, then that's a risk point for you. And, you know, we've seen that in things like Colors and Faker, where even in these really, really well-used packages, which were, you know, they're super simple, so they were fairly secure anyway. But, you know, that a single maintainer, because there's no governance model there, you know, that is a danger point. And we see that, you know, a lot, I think, in those very, very big package ecosystems like NPM. You know, you probably see it slightly less in Python, I think, because the ecosystem is smaller and you tend to have one choice for a particular package, whereas in the JavaScript world, it's like, I need to do something. Well, here's 50 different packages that do exactly the same thing. I'm sure I'm going to be shouted at by all my JavaScript friends for my complete lack of knowledge about the JavaScript ecosystem there, but yeah.
I mean, there's some great points in there. The OpenSSF, especially, there will be an OpenSSF day at the Open Source Summit in Austin next week. My itinerary of conference attendance is relatively packed.
Are you in Austin?
Yeah, I'll be there for the week.
I'm also there, so
fantastic.
We'll hook up in person. Come by the Sneak booth.
Yeah, precisely. I'll be meandering around for the week.
Right, I know we've almost managed to fill this slot, but I need to do some housekeeping things super quick. Right, add stream. Okay, so I just wanted to talk about the fantastic growing DevSecCon community. We are now 13 chapters in 12 countries. I know you folks are involved in a couple of these, I think, the London and the Wales ones, but we've got chapters all over the place now: Greece, Hungary, Switzerland, Germany, Canada. Yeah, it's great. And, you know, it's fantastic to see this community growing. So please do get involved with your local DevSecCon chapter. If you fancy starting a chapter in your area, just reach out through the website or through the Discord, and I'm sure that we'd love to have more chapters getting started there. All the proceeds from this conference will be going to charities, particularly focused on driving inclusiveness within technology, and there'll be a split across the 3 regions, APJ, EMEA, and the Americas, looking to support local organizations that are leading the movement to address inequality in the tech sector and drive inclusion and diversity within our local communities. Please, as I said, go and visit our sponsors. Let's go to this slide first. So thank you to our sponsors, I should say first: Sneak, Sysdig, Contrast Security, CodeFresh, MuleSoft, Stackhawk, Bright, Psycode, Blue Bracket. Without sponsors, these community conferences could not possibly happen. So thank you to all of those folks for taking part. And I know a bunch of them have got virtual booths in the Hopin environment. So please do pop along there, have a look at what their offer is, have a chat to some of their folks. I'm sure some of them have got some great giveaways as well. So you may even be able to bag yourself some swag. The DevSecOps Leadership Awards are now in their 4th year. This is coming up again. We've got a number of categories there that you can go along and nominate people for on the DevSecCon website. So please go along and do that. Let me just check my list here of other housekeeping things I need to say. I think that is about it. Are we back on time again now? I think we're right. We are. So, who's Andy? Do you want to introduce the next speaker?
Yes, absolutely. So, looking forward to hearing from Aqua. from the Simar Singh. We'll be hearing about cloud native incident response. So how we automate the many different, and good afternoon, wherever you are.
Hi, Simar.
Good morning for me. It's 6 a.m. I'm in Canada right now.
Fantastic. Thank you for getting up out of bed early to join us. It's very much appreciated. Would you like to share your screen, sir? And I'll get you all in the ready to go. There we go.
Just gonna make it bigger. All right, can you folks see the big presentation?
I think we can. Oh, it's just it's redrawing extremely slowly at the minute for some reason. There we go. Got there in the end. Fantastic. So the floor is yours.
All right. Hi, this is Simar. I work at Aqua, and I'll be talking about how you can automate incident response with Posty for cloud native risks. I was just listening to the last presentation, and then it was great to hear that security is people's problem first, and not a tech problem. That was great to hear. So I'll just be adding on that a little bit today. So just the brief agenda for today's talk will be, some patterns that we see, challenges with those, and some solutions that I have, and a quick demo and beyond. So we've all heard or overheard in the office or wherever we are that security is a requirement and not an option. And for that, we always end up running multiple scanning solutions. These are just some of them to list, but then you also in the morning wake up with this mailbox full of notifications, and then you start to realize what you signed up for. So alert fatigue is real. Nobody wants to see this. Everyone wants to strive for inbox, or at least I do. And this was very well documented in a PagerDuty blog. People who will know this better than anyone else. And they came up with some really good recommendations for what makes a good alert. And some of them I'll just summarize. Are a good alert. Let's say you're in the midnight, struggling midnight, and you just wake up with a page. Should be actionable. You should be able to know what to do with it. It should be descriptive, but most importantly, should go to the right people. You don't want to get a page for something that you have no control over or you don't know what to do. But what makes an ideal alert would be all that plus if it was automated. And now there are many definitions, and people go they make various definitions of like what it means to be automated. Some call it self-healing, some call it self-resolving, automated playbooks, whatever you might call it. But ideally, the alert should know what to do when it comes, or at least have a course of action before a human operator gets involved. Because as we all know, human time is expensive, and some of these alerts can get repetitive, especially if they are known to the person before it happened. So the title of my talk, SOAR with Posty, is actually an acronym which stands for Security Orchestration Automation Response. So for this talk, I'll be focusing on the automation and the response piece of Posty and what you can do today with it. So without further ado, I'll actually introduce Alpha Posty. What is Posty? Posty is essentially a message routing system. So it takes messages from one producer, operates over them, and then sends it out to a different consumer or a place that's listening for them. It is policy-based, so we use Rego to basically design our routing for all the messages that come in. So you can write your own policies depending on how you want these messages to be routed. And then most importantly, there is enforcement on alerts that you get. So you can essentially have what we call post actions, depending on what you want to do to them. So I'll give some of those examples today, and we'll see a few demos of that as well. So this is a high-level overview. Don't be worried if you can't understand the details. But essentially, there are three parts to Postly. First is the input, which is essentially where all the production of messages happens. So this could be any producer of messages, could be your monitoring app, could be your application itself, could be anything. And then the second is the process, which is Postly itself. So this is where your policy-based routing comes in. Messages are sent, they're templated out before they're sent to external applications, and basically the whole engine, the policy engine lives within this process. And the last bit is execution, so where the messages are actually sent out from Postly to other applications. So we wanted this experience of using Postly be as seamless as possible with our existing apps. So Trivy is a vulnerability scanner that you can use today to scan a bunch of images or other artifacts, and Tracy is a runtime protection scanner that you can set up on your machine and have runtime alerts come to you. So today, Postly and Tracy and Postly and Trivy work seamlessly together, and that's not to say that these are the only things that work together. These are just some of the examples I'll be giving today to showcase how Postly can help you automate the risks that you have. So you can have any producer again, and then Postly and that producer can talk over a webhook and work alongside each other. So for example, Postly and Tracy can work like this. So Tracy, as I mentioned, runs on the host. It basically monitors for any runtime alerts that you may have while you're using your system or your node. And Tracy will basically observe this behavior using eBPF technology, and then generate an event and send it out to a consumer like Postly. So Postly gets that, and then this is where the enforcement or the Postly actions happen, where Postly can, you can tell Postly what to do when a certain kind of event happens. So for instance, you can have a process be terminated if it's doing malicious activity, for example, and Postly can enforce that on the node after it receives the event from Tracy. So very quick demo. On the right side of the screen, you can see the configuration of Postly. It's basically a YAML file you can configure with certain rules. So the input that you see there is actually a Rego policy. It's a very simple Rego policy that looks for a certain signature. And I'm going to start Postly, and it's going to start listening for requests. In the middle, I'll start Tracy, which is basically running as a Docker container. And then I'm going to specify the output to go into a webhook, which is the webhook where Postly is listening. So then Tracy is going to start up. It's going to start looking at stuff. And this is just a test instance. So right away, you can see that there was, the Kubernetes service account token was accessed. And then Postly took that and sent it over to a webhook, because that was one of the outputs that we configured Postly to do. So you can see all the historical events that have come in the past as well. This is just a way to look at them, and this is the actual output of the Tracy event that has come in. So these are all the details that the producer that has sent us, in this case Tracy, and Postly has forwarded them to a webhook. So that's one.
Simar, we're just having some slight problems with your screen not updating. Can you just try unsharing and resharing again?
Okay.
If that fixes it. I just didn't want to carry on. Just super slow updating for some reason.
Is it?
Do you want to try sharing it, and if I just remove it from there and unshare and reshare? Otherwise, we may well just have to accept it. But
all right.
whatever.
I try resharing right now. Is it updated?
Okay. I'm not sure whether it's your connection or whether it's PowerPoint or yeah, it's still super slow updating.
Yeah, it's that's unfortunate. I'm trying to see what my screen is showing right now in the presenter pane. Yeah, it is really slow. I can see that too. Let me see if I could try something else really quickly here. 1 second. Sorry about that. 1 second. I'll try to share the slides from StreamYard. That will help. It will not let me because of size is more than 50 megabytes. That's unfortunate. Okay. We'll try to see what I can do here.
Simar, it did seem to work whenever something was updating, so I don't know whether you can bring the terminal window up and just drag it around so it senses the refresh. Try that.
Okay. Yeah, I think I'll just go. Yeah, every time I change a slide, it's for some reason it's very slow to update. Yeah, not sure what's going on. Try a different screen maybe. Is that any better? I'm not sure. Like, is it updating better now than before?
Yeah, that seems to be a lot better. I don't know what it'll be like with the terminal window.
Okay. All right. Well, I'll say what we can. So I'll just start at this slide. I was saying Posty and Tracy can work together, and then Posty is just one of the producers that Tracy can. Tracy is just one of the producers that Posty can use. Tracy is powered by UPF. It can generate events when it sees malicious behavior. These events can be sent to Posty, and then Posty can act upon them in any way. So, for example, if you tell Posty to terminate any process that is malicious that is observed by Tracy, you can do that, or other things as well. In the interest of time, I'll skip over and talk about Trivy and Posty. So Trivy is a vulnerability scanner that can scan your images, other artifacts, and then these reports that Trivy and this output that Trivy has can be sent to Posty, and then Posty can take actions like, if the base image is vulnerable, it can update that. if you want to remove that image altogether from your cluster, you can do that as well. So essentially, it's all in your hands. What actions you want to do with Posty. So this is where the automation piece happens for Posty. So if there are things that happen very often, like for example, you think that you scan images often, and then you expect them to be vulnerable. As vulnerabilities happen over time, one common action could be update that image that is vulnerable, or issue a Jira ticket. For instance, we have several integrations for Posty that come out of the box. For example, sending messages in Slack, or Microsoft Teams, or creating a Jira ticket, or any webhook that might be listening. So some of those I was going to demo in the slides today, of how you can basically take an event, create a Jira ticket out of it, so that the operator can come tomorrow morning and doesn't have to be woken up at midnight to handle the alert. So you can create a ticket, they can come take a look at tomorrow morning and act appropriately. So the scan results, for instance, can be sent as the content of a Jira ticket to Jira, and you can take a look at what happened when you were trying to scan that. So in the interest of time, let me just quickly check how much is left. Well, I'm already past it. So, these projects that I mentioned today are all open source, Posty, Tracy, and Trivi. We welcome your contributions, and we look forward to hearing from you if you have any ideas, or if there are integrations that you'd like to build. As I mentioned, Posty works with any producer. It just listens on a webhook. So anything that any producer wants to send to it, it can handle. And that's about it. Thank you for listening, and sorry about the share.
Thanks for that. So I'm sorry about the technical problems there. We'll get one of the team to reach out to you, and maybe we can record your talk again, so that we can get it on YouTube with the demos and stuff in it. I know I was super interested in all those projects, so I would like to see it in its full glory. But thank you so much for joining us. I know it's been an early start for you, but well, I'll get one of the team to reach out to you behind the scenes, and we'll see if we can get that talk added.
Thank you for having me. Thanks, everyone.
Thank you. Right. Okay, we're moving swiftly on. Our next speaker is Alex Ilgiev. Alex is a senior security researcher at SciCode, and going to be talking about GitHub Actions. So, Alex, if you want to share your screen, we'll get.
Yeah, share my screen. Yeah. Just
hopefully your screen will work.
Yeah. Can you see it, right?
The floor is yours.
Yeah. Thanks for introducing me, Matt. So today's topic will be GitHub Actions security landscape. I'm Alex from SciCode, and I'll present you our latest unique research of GitHub Actions internals, including how we discover and disclose some critical vulnerabilities in several popular open source projects that were using GitHub Actions. So let's start with the agenda. It will explore in this talk the security landscape of GitHub Actions. And first, we'll learn what is GitHub Actions and why is it really a powerful build system. Then we'll learn what kind of misconfigurations it can have. We'll focus on the code injection as the main scenario of the exploit. Then we'll understand what could be the consequences by exploring the GitHub Actions internals. And finally, we'll explore some of the possible mitigations to stop such attacks. So as I previously said, I'm Alex Ilgiev. I'm a senior security researcher at SciCode. Previously, I was investigating malware threats and checkpoint research. I love anything that relates to security and hacking, so don't hesitate to reach out to me through Twitter. So let's talk a bit about GitHub. For most of its history, GitHub was all about storing source code. In 2018, they announced that they're going in a different but related direction by launching GitHub Actions, which is a CI/CD platform allowing GitHub developers to automate development workflows easily. Since then, GitHub Actions has become extremely popular, mainly due to its rich marketplace, containing more than 12,000 actions and free hosted runners for public repositories. By now, GitHub has over 73 million developers and more than 200 million repositories. Before we go deeper into the misconfigurations we found, let's first understand the possible usages of GitHub Actions. The most popular use case would be probably building your code into a container and uploading to your chosen registry. Could be Docker Hub, JFrog, ECR, GCR, and many, many more. Other possible usages could be creating scheduled tasks to scan vulnerabilities in your repository. It could be running tests or static analysis for a pull request. Could be automatic labeling for issues based on some predefined logic. It could be sending issues to ticket handling system and much, much more. So what is GitHub Actions workflow looks like? So basically it is a YAML file that contains a name, a triggered event, and jobs. The triggered event in this case is a push event. This means that for every new push to the repository, for every commit, this event will be triggered. And the job in this example contains a single step that just echoes hello world. If we put this workflow file into the path of .github/workflows path in GitHub, and that's it. GitHub Action Service will trigger this workflow whenever we push a new code to the repository. Simple as that. To understand the vulnerabilities, we need first to understand some core mechanics of GitHub Actions. The entity that runs the job is called GitHub Runner, and it is actually an open source project maintained by GitHub. This runner fetches the job from GitHub Action Service and executes them. This runner could be run either on a GitHub hosted machine or which is the more popular solution, or on a self-hosted machine. If a GitHub hosted machine is used, it will also run as an ephemeral environment. This means that each job will run on completely clean VM isolated machine, and once the job is over, the environment will be deleted. In addition, for each job, GitHub creates a temporary token, which can be used to access a GitHub API for various tasks. Such tasks could be updating issues, comments, pull requests, code, and more. So let's understand this GitHub token and why it is used here. The standard method to access GitHub API is via personal access token. This token contains the same permissions as the user who issued it. This token has two main drawbacks. It can be quite permissive because it isn't limited to specific repositories, and it is usually active for a long duration, which is problematic if it leaks. To overcome using these tokens, GitHub came up with an idea to create a temporary token called GitHub token on each invocation. This token receives default write permissions for most of the events, but it has several limitations. This token scope is for the repository on which the actions are executed, and this token is valid during the action executed period or 24 hours at most. It uses default parameters for many actions, for example, the checkout action. And for pull requests for public repositories will receive at most read permissions for this GitHub token. Another core mechanic of GitHub Actions is secrets. Using secrets is an integral part of creating meaningful GitHub Actions workflows. When you store secrets in GitHub, they are well encrypted, and whenever an action is requesting one of the secrets, it is decrypted and sent as part of the running command. Examples of such secrets could be cloud tokens, such as AWS, GCP, Azure access tokens, It could be artifact registry tokens such as Docker Hub and more. GitHub separates secrets into 3 layers of exposure: organization, repository, and repository environment. The first one is secrets defined in an organization. These secrets are exposed to all the repositories, to all the workflows in all the repositories in that organization. In addition, you could also define for each secret, it could be limited to specific repositories. The second exposure level is on the repository level, which means that it will be exposed to all the actions in that repository. And the third one is secretly defined in repository environment, which we'll talk later in the mitigation part. Now that we learned what GitHub Actions and why is it a powerful CI/CD system, let's understand what code injection is. We created a sample workflow that does the following. This workflow will be triggered whenever a new issue is created, a new issue on GitHub. And it contains one job that's called issue check and single step, and we'll run this bash script. This script checks that if that issue title contains the word bug in the issue, it will trigger a GitHub API request and update that issue with the label bug. This workflow could be used to, for example, to triage issues easily. So in this workflow, we can see this curly brackets, double curly brackets. This is another mechanism that allows workflow developers to use additional information from the triggered event. In this example, we have several such usages. We have this usage for the issue title. We have the usage of the secret of GitHub token. We're using the GitHub token, which we described previously. And we have the issue URL, which we are using to invoke the appropriate API call. So at first sight, this workflow looks innocent, but actually a malicious title could alter this bash script and run a control code. For example, if we send this title for that workflow, this title actually insert the code to the runner and manage to execute this code. It managed to execute this figlet, which prints this pretty psycho text. Because we managed to execute code and on the runner. So is it a bug or a feature? You may think this is a bug, but it is actually mentioned on GitHub documentation. It says that when you create workflows, you should always consider whether your code might execute untrusted input from the attacker. Well, but are all the project owners or maintainers aware of this? Let's check it out. GitHub released a new web tool called GitHub Code Search, which is still in its preview phase. You're welcome to sign up and try it out. So naturally, we ran a few queries using that tool, and we were shocked by the amount of results we found. We looked for suspicious patterns, such as the run command and usage of untrusted input inside the run command, and find many results vulnerable for these bugs. Not every vulnerability is exploitable, and we met a similar situation. Many repositories that contain such injection issues had conditional statements before the vulnerable command, which denied the potential attack. While it reduced the attack surface, we still suggest such repositories to remove the vulnerable command because these conditional statements could be removed in the future. So we can say it loud that we found an extremely widespread issue. We identified dozens of repositories that share these vulnerabilities in their GitHub Actions workflow. For each repository, we reported it to the maintainers and they fixed it immediately. Out of these dozens of repositories, you can observe the most popular ones. This list contains the following products: Liquibase, which is a popular tool to deploy database schema changes; Dynamo, which is a visual programming tool that Autodesk sponsors; Fauna, which is a transactional database; Wire, which is an open source communication platform; Astro is a static site builder, and much, much more. Liquibase on its own claims that its product has been downloaded 75 million times. So we can safely say that when we sum up the users of all these tools, we could reach millions of users. The consequences of such build compromise are quite disastrous. The first major impact is exposing secrets of the vulnerable workflow. Such secrets could be cloud tokens and additional sensitive assets. The second major impact is the ability of the attacker to commit malicious code into the repository. This can cause a critical supply chain incident, as an attacker can introduce backdoors deployed to end users or organization environments. A much smaller risk would be the malicious actor ability to run botnets or crypto miners using the runner infrastructure. So to demonstrate the ability of the attacker to expose secrets, we created an intentionally vulnerable workflow, which will follow us in the example. This workflow will be triggered whenever a new issue is created, similar as previously. It will contain a single job. First, it will contain an environment variable, GitHub token, that will receive the value of the GitHub token. Soon we'll see why we defined it. And contains a single job that's called a vuln job and 3 steps. The first steps would be a checkout command, which basically does git clone to the repository to the runner environment. Then it will print the issue title and the issue description. And finally, it will call a GitHub API and update this issue with a new label that this will be new issue. In this process, it will use another secret that's called the bot token. So as we showed previously, this run step is vulnerable to code injection. We are not sanitizing the title, the issue title and the issue body. This means that an attacker could compromise the build workflow in this exact step. What could be the consequences of such attack? First, an attacker could get the GitHub token and use it for malicious purposes, and it could get the bot token and also use it for malicious purposes. So we should try to understand how an attacker could do that for both past and future steps that have been used in this action. To achieve that, we created a small setup to test the runner internals. Instead of repeating the process of tweaking the injection and inspecting the results, we wanted to create a reverse shell to ease the exploration. For that, we used a popular tool, ngrok. If you're not familiar with it, it allows you to tunnel traffic, whether HTTP or TCP, to a personal computer, even when it's behind the NAT or firewall. So we run the following steps. First, we set up an ngrok on TCP and on port 10,000, which is a chosen local port. Then we received from ngrok cloud the endpoint, which we'll use later in the remote script. We run netcat on port 10,000 to listen for the reverse shell. And finally, we could send the malicious script to finalize the reverse shell. So when we send this specific issue title for the specific endpoint we received from the ngrok, we will get our reverse shell almost immediately. After we got this, we started scanning the machine and do some reconnaissance there. We won't overload you with all the details. You're welcome to check the full technical blog for that. But we show some of their main findings in the next part. So let's go back to our previous example. The first method would be getting secrets through environment variables. Because we defined the GitHub token through environment variable, an attacker could simply enumerate all the variables and receive that easily. You can observe the code the attacker could execute to fetch the token. This is pretty simple. The second method attacker could apply for stealing the token is through the checkout step. We explained the checkout command is basically a git clone to the repository and creates a local instance of your code. Behind the scenes, it sends the GitHub token as a default parameter to external action. In addition, whenever we clone a repository using credentials, the Git utility creates a .git/config file containing the credential used to clone that repository. So if that checkout step was used as an attacker, we can fetch that git/config file to get authorization and pipe it through base64 decoding. And we get our GitHub token again. The third method is a bit more complex. During our reconnaissance, we understood that each run command, we have two run commands, each run command, before it's been executed, it's also saved as a shell file in the runner environment. So because our attacker is has got code execution at this point, it not seeing the second run command yet, so it sees only this one. So when we going into runner temp directory, which contains this shell file, we have a single shell file that contains the same script as we see in the YAML file, but instead of these placeholders, we have the real values that GitHub Action Service inserted. So potentially, if we'll manage to get, if this shell file contains secrets in it, so we, as an attacker, will manage to get this if we manage to get the script. The only issue that we don't have the second script yet because we managed to execute only on the first one. The possible solution, a simple solution, will be to put some persistent script on the runner and wait when the second script will be written to the disk, to that folder, and when it happens, we can fetch it immediately. So our steps would be creating some server that records all post requests, creating some scripts that record modified shell script in that directory, and send them to some designated server. We pack that script in some Docker container to ease the deployment and run it in the detach mode. This will be the running command. We soon see how it works in a demo. These were the simple methods attacker could apply. Sophisticated attackers could apply a more advanced method. For example, inspecting the memory of the runner worker process or trying to extract some secrets from there. Could be monitoring the created processes or monitoring the network traffic and etc. So let's start with the demos. For the first demo, we'll show how we managed to exfiltrate the secrets in two steps. In the first step, we'll exfiltrate the GitHub token, which is quite simple. And the second step, we exfiltrate the bot token, which comes as after we put the persistent script. So let's see the demo. First, we set up the server. Then this is our demo repository. We're sending the malicious issue title. This title contains several commands. As explained, it will exfiltrate it in two steps. The first one will be sending the GitHub token to our server, as we can see now. And the second step, we put some Docker container that will monitor that whenever the new file will be written, it will be sent. You could see that on the second step, we received the entire script, as we've seen in the example, together with the secrets we wanted to fetch. So for the second demo, we will commit code to the repository. For that, we created some simple another bash script that receives the file that we want to commit and the path. And it does some Git configurations, very simple. It fetches the file and just Git commit and Git push it. It's quite simple, nothing fancy here. On the runner part, we're going to fetch this script, which on the left side, give it the right permissions and just run it. So let's see that in demo. You can see our repository contains one folder and a file. We're creating a new issue. This issue has several steps, as we previously showed. First, it's fetching the script. Then it gives it the right permissions. and then it runs the script together with its input. The first one will be the file that we want to commit, and second will be the path of that file. So now that we check the repository, we can see that has an additional file that we committed. Okay. It has an additional file that we just managed to commit. In addition, you could see the commit message. This is the innocent commit message which we created, and the maintainer name which we managed to forge. Pretty cool, right? So after we show the possible consequences of build pipeline compromise, let's see how can we mitigate it. The first one will be to avoid run steps. For example, instead of issuing a curl request to GitHub API to update the issue with specific label, we can use an external action, the code labeler, in this example, that does exactly the same. It contains the parameter for the label we want to update. Even if this issue title contains some code, it won't be executed because it's sanitized as an input parameter. The second mitigation, which is the most effective in this method, will be to sanitizing the input. For example, instead of using the issue title and the body inside the run script, we could extract it and define it as an intermediate environment variable, like in this example, and use that variable inside the run script. So same way as previously, even if this title or description will contain code, it won't be executed because it's treated as a text. Another effective method for post-exploitation would be to limit token permissions. Inside our YAML file, inside the workflow file, we could add a permission tag, which will indicate the permissions that the GitHub token will receive. Because in our example, we use the GitHub token only to clone the code and to update the issue, we don't need more than these permissions for the GitHub token. This is an effective method for any kind of exploitation, not only this one. So even if the attacker has managed to exploit your vulnerable workflow and execute code, he won't be able to do much with lower permissions. Another method will be to require approval for outside collaborators, which is mainly applied for public repositories. GitHub has introduced some mitigations that new collaborators for repositories won't be able to run workflows unless some maintainer will approve them manually, which is this option. This is a quite good mitigation, but a more robust one would be to require approval for every commit that outside collaborators make, because this could be bypassed quite easily. And the last mitigation would be to use environments and branch protection. This is quite a new mitigation that happens in a GitHub Enterprise. It allows you to define several environments for your workflows. For example, production, staging, testing. Each such environment contains its specific secrets. And this environment could be protected for branch protection rules. So this is a quite effective method to protect your secrets. So what will be the takeaways from this talk? Sorry. First of all, even when GitHub does most of the work for handling the build pipeline for you and for the security, including ephemeral environments and VM-based isolation, we are showing that it still can be compromised. This is the most important takeaway from this talk. As we saw in GitHub best practices paper, it delegates some of the responsibilities for securing the workflows to the developers. The issue, I'm a developer myself. I know that developers make mistakes, so this should be handled carefully. The consequences of build pipeline compromise can be quite disastrous and could expose sensitive secrets and cause potential supply chain attacks. And last one, GitHub gives you the tools for securing the build, such as limiting permissions and secrets, sanitizing input variables, and more. We highly advise you to use them. So that's it. Thank you very much for listening. Thank you for DevSecCon for hosting me here. You're welcome to check the full technical details in our blog, in Cycled blog. And if you have any questions, I'm welcome to answer.
Thank you, Alex. That was super interesting. I've got a question. I mean, have you seen any or heard of any examples of these kind of attacks happening in the wild?
Personally, I haven't, but supply chain attacks happens in the wild all the time. And this is just some specific potential supply chain attack. And we didn't hear it, but it doesn't matter that it didn't happen.
Mm.
We just want to prevent it from happening.
Yeah, I mean, I suppose it's, you know, obviously having access to tools like GitHub has been fantastically productive in lots of ways, hasn't it? Mm-hmm. You know, that people no longer have to kind of run all this infrastructure themselves, but, you know, it definitely does open up the possibilities for attacks. And I think, you know, I mean, as more and more tools start to become parts of these sort of
it develops very quickly. I mean, this attack landscape will increase over the years. I can assure that.
Yeah, I mean, you can see there's already a move to push editors into cloud-based platforms, isn't there? Mm-hmm. You know, so you start to think about what the possibilities are for being able to attack your code right in the editor is also worrying. Right. Well, I think that's all the questions we had time for. So thank you, Alex. Hopefully you'll stick around for the rest of the conference.
Thank you very much. Thank you for hosting.
Absolute pleasure. Thank you for contributing. Right. So Jamie, we're nearly there. We've lost Andy. Andy's he's a busy guy, I know, so he's had to go off and do some real work. So we are now, I think we've got about a just less than a 10-minute break that again, we're going to desperately try and fill with chat. So do hang around if you are interested in Jamie and I waffling on. Otherwise, yeah, absolutely. Thank you for the banner. So live now on the Sneak booth, if you go into the Hopin platform, go to the Expo section, click on the Sneak booth. There's a live session on finding the best open source packages for your apps. I've seen this session before. It's super interesting. So please do go along there and check out that session. What else have we got? So I think we've got two more great talks in this EMEA section of DevSecCon24. I did want briefly to talk about, let's get my slides back up here. We talked a little bit about all the fantastic DevSecCon communities that are worldwide and growing. And we also have some local chapter events that you can go to over the next month. So in the Netherlands, my friend and colleague Laurent Tal, who works in the developer relations team at Sneak, is going to be presenting Stranger Danger, Your Node.js Attack Surface Just Got Bigger. It's a great talk. Laurent's a very entertaining speaker. So if you're in the Netherlands, I'm not sure whether these are in person or virtual ones, and nobody has told me yet. So and they may be in person, but you can go and check on devseccon.com/events. Our Greek chapter has got a talk on com hijacking voodoo. Wow, that sounds interesting, from Nikos Vourdas. And in France on June the 22nd, we've got CTF ou CTF PA. You're a French speaker, Jamie?
Yeah, I think that's to CTF or not.
I think it is. Yeah, even my GCSE level French can just about translate that. So that should be super interesting. So if you're in any of those regions, do pop along to one of those events and support your local DevSecCon community. So what time are we on? We've got 5 minutes. So what can we talk about, Jamie? Why don't you tell me a bit about control plane for folks who don't know who control plane are?
Yeah, sure. So Control Plane is a consulting and auditing firm, We also run, speaking of CTF events, we also run those. We run them at places like KubeCon and other conferences, but we can also run them privately for firms as well. So we'll come in, give them servers to hack, give them a helping hand if they need it, and then also show them how they can defend against those vulnerabilities as well.
I know those are super popular KubeCon sessions, and usually delivered by my good friend Lewis Denham Parry, who runs the DevSecCon Wales chapter these days, I believe, for you guys.
Yeah, that's absolutely right. Yeah, that's where I'm based as well. So I'm just outside Newport in South Wales. And I think Lewis is doing a talk later today, isn't he, in the Americas?
He may well be.
I think he's on the agenda later today. So
right,
it's kind of strange. We had sort of two people from America in the EMEA section, and then Lewis is giving the talk in the Americas. But I guess it's all speaker schedule.
And we should give a plug to Andy's book. Andy's written one of the great books on Kubernetes security, together with Michael Hasselblau, right?
That's right. Yeah, it's Hacking Kubernetes. Yeah, the O'Reilly book.
O'Reilly. And Andy, I'll have the kickback for that plug later.
If anyone wants to sample that and see if it's right for them, there's a free download of the first half of that book on the Control Plane website as well. So that's at control-plane.io.
Fantastic. Yeah, it's a great book. I've got it somewhere on my bookshelf. So yeah, that's a great. And Andy's speaking at Open Source Summit in Austin next week, where Sneak will also have a booth. So if you want to talk anything about Sneak or anything about developer first security, do come along and say hello. I will be there along with some others from the developer relations team at Sneak. We should also give another shout out to all our fantastic sponsors. Thank you to everybody for sponsoring. As I said, I'm a bit like a stuck record on this, but without sponsors, community conferences could not happen. We absolutely rely on all these kind folks giving us sponsorship in order to put these events on. So thank you to Sneak, Sysdig, Contrast Security, CodeFresh, MuleSoft, StackHawk, Bright, Psycode, Blue Bracket. So fantastic, and please do go and visit these folks in the expo in Hopin and have a chat to them, see what their products do. All of these are in the field of developer security. So yeah, right.
It's speaking of Hopin, it's worth just saying that in the replay section, the team are going to put the whole chunk, so the APJ section will be there shortly if it's not there already. This EMEA session will be there as a whole shortly after we finish, and then the same for the Americas. And then after that, the team are going to go back and sort of chop up each of those talks into separate YouTube entries as well. So they should be available. I don't want to commit them to anything, but I imagine in the coming days.
They've all been up since about 2 a.m. this morning. There's a whole team of people behind the scenes who we should also thank, to be honest. We get to sit here and waffle on for hours, but the folks who work behind the scenes who make all this happen, Sam Hepper and her team actually do the real work of putting these events on. So thank you to all those folks for keeping us on screen and putting together this fantastic conference. So I think we're just about ready for the next speaker. Do you want to introduce Eva, Jamie?
Yeah, certainly. So we can bring Eva to the stage, please. I'll just turn these banners off. Okay, yeah. So
hello, Eva.
Hello.
Hey, Eva. So
I'm
Eva
glad
is
to be here.
thank you for coming. Eva is the principal product security engineer at the Auth product unit of Okta. And today she's going to talk to us about lessons learned from helping scale a product security program from startup to acquisition. So Eva, over to you.
Thank you. So hi, everyone. I'm super excited to be here. And in the next 30 minutes, I'll share what I learned from being part of a product security team from a startup to an acquisition. A few more details for me. As said, I'm a principal product security engineer at Auth0. Auth0 is a product unit of Okta. I joined Auth0 back in 2018. Back then, the company had roughly 400 employees, and the product security team was doing small steps. Fast forward last year, Auth0 was acquired by Okta, and at that point, Auth0 had roughly 1,000 employees and a mature product security program. So this talk is about those 4 years in the journey and what I learned through that journey. On my free time, I do dance classes, ballet and contemporary. I play the piano, the clarinet. I love outdoor activities. And this is my dog, Trufa, which I also love spending time with. Sort of a disclaimer what this talk is about and what I'll cover and what not. This is about my observations and the things that I learned through that journey of a zero from a startup to a mid-sized company and myself being part of the product security team. This talk is not about how zero product security program or team look like, what decisions we took, and so on. And to that regard, the rest of the talk will be about a fictional product security team and the different stages that go. For example, a small team, short staff, laying the foundations, how you mature, and how we scale. And with that, let's say that there is a company and you get hired as one of the first 2 product security engineers, and the new product security team is formed. One question you may have is where to start? And in 2 big buckets, we can split it into, should I focus on the security of the new features, or should I focus on the security of the existing product? If you were to focus on the first one, on the security of the new features, you will successfully start applying the shift left approach. You can start having design reviews, security reviews during the design, and this will be effective in stopping vulnerabilities from entering the code in new product features. But if you were to only focus on this one, any undiscovered vulnerabilities in the existing product would still remain, and this would pose a significant security risk. Now, if we are to go on the other side, let's say we're focusing only on the security of the existing product. Here, yes, we will uncover vulnerabilities, and based on that, we will be able to assess what is the risk that we have and plan mitigating it. But we will suffer the same thing on the new features. If we do nothing for the new features, we will have vulnerabilities introduced there. Of course, it's not a one or the other. There is a balance. But my suggestion is during the very early stages, at least for the first couple of quarters, you need to give some attention to the existing product so that you have a baseline on what is your security posture up to that moment. And at the same point, you will start rolling out processes and tools to help on the security by design journey. On the topic on security of the existing product, when you first join a company, you may not know the product, and asking the question where the bodies are buried, where the security bugs are hidden, it may be a difficult or challenging task. My suggestion is ask engineers. The engineers who develop the product, who develop the features, know when they took a shortcut, know when they did things not perfectly. When they did it, they didn't know the impact of it, but if you ask them, I'm pretty sure they can point you to some pretty interesting directions. If you want to make it a bit of a more fun activity, collaborate with your engineering peers and conduct some engineering-wide bug hunting days. So engineering teams and security teams group together to hunt some security bugs. And the third one is, it's possible that the company you're joining already had done a third-party pen test, but my suggestion is have another one at that point that you're forming the product security team and you're starting to roll out a program, because this will give you a baseline of the existing posture. You will know how the product looks like from the external vulnerability surface. This is for the existing product, but we said we also need to do some work on the new features. And a question we will always ask, whether it's in this very early stage or further down the road, is how we prioritize how we work on assessing, on consulting on those new features. What I've seen that works really well is a risk assessment questionnaire. A risk assessment questionnaire is a list of questions that engineering teams need to fill during the start of their design. And it's a list of questions that help determine risk. Some examples are, does the feature you're building change how authentication authorization work? Are you going to do some sort of encryption? Do you handle secret, sensitive data or personal data, and so on? and try that the answers in those questions have a yes and a no. And the reason is we want, based on the answers, to quantify the risk. And this is where you would need to create a risk scoring algorithm. Now, in the beginning, the risk scoring algorithm will not be perfect. And the reason is when you create it, you don't have past data to validate it against. So maybe in the beginning, you can use a combination of your gut feeling and what the risk scoring algorithm says, but this means you will need eventually to iterate on that algorithm. So based on that, with that questionnaire that is filled by engineering teams, and ideally it automatically provides the risk score of this project, you can assess the risk of an upcoming project. And this allows you to work on a risk-based prioritization. You can start working on design reviews for high-risk projects, and depending on your capacity, you could move to more medium-risk ones. Now, this doesn't mean that for medium and low-risk ones, we offer nothing to our engineers. And this is where I think that security best practice documentation is a good start in this very early stage of a product security program. It can be used both for engineering training, but also as a material to point your engineers for projects that you will not be able to consult them as closely as you would like. And on that regard, it's sometimes difficult to see how you prioritize. There are so many things we want to educate our engineers on security best practices, and it's not always clear how to start. My suggestion is map every question of the risk assessment questionnaire, map it to a security best practice document. And to go back to the example, if there is a question that says, are you using encryption? And they have said yes, there should be a security best practice document on how to implement encryption correctly. And that document needs to be short and actionable. And like those two are quite important, the short and the actionable. And the reason is that our engineers need information to make their implementation and their design more secure. It's possible that you will want to create a document that explains why encryption, when do we use encryption, and a bit more of a training material. But my suggestion is keep them separate and have at least one document that is, how do I do it securely? How do I design and how do I implement something securely? On the security testing tools, in this very early stage, it's very possible that there is no budget for commercial tools. This doesn't mean that you cannot roll out some security testing. Evaluate them very well before the integration. The fact that they're open source doesn't mean that rolling them out, teaching the engineers to use them and to make actions based on the findings doesn't mean that it has zero cost. On the contrary. Another thing is roll out security tools progressively. If you want to roll out many tools, roll them little by little. And also, if you want to roll out just one tool, don't roll it out to the whole organization. Again, in both cases, the point is we don't want to overwhelm our engineers because they will not have the time to learn the new process, to learn the new tool, and take action on the findings. Another point is integrating to CI/CD, and especially for security testing tools like static analysis or software composition analysis like Sneak, you want to be able to add those security testing tools as a check in your PRs, because you don't have time for manual code reviews, especially in this very early stage. But those testing tools can be an automated security code review. The final thing, and I know it feels obvious, is don't roll out a security tool with high number of false positives. Doing that, you train your engineers that security testing tools do not give valuable results, and you train them to not really pay attention to them. So roll out tools that have a low number of false positives, or do the first trials to give to the rest of the engineers a clear state. Vulnerability management. I said in the beginning that during this first laying the foundations of a product security program, you will do some security testing on the existing product. And also, we just said that we will launch out some security testing tools. In both cases, this means that we will have vulnerabilities. As a first step on creating a vulnerability management program, create something lightweight. It can be as lightweight as the diagram I have on the side. And something very important is to train your teams, the engineering, the product, and the security teams on this new process. Remember that vulnerability management is not a process owned only by security. It's a collaborative process between engineering, product, and security, and the success of it depends on all those teams. Finally, I know that we as security people, we like SLAs. If it's a high vulnerability, it needs to be fixed in X amount of days. But don't rush into creating strict SLAs if this is not feasible to be met. You are just rolling out a vulnerability management program. You're building the foundations for security product program. It's possible that SLAs will not be met. And putting strict SLAs from now, you're mentally training the rest of the organization that strict SLAs for security issues are not that strict. And you'll have heard me in the last couple of slides saying how you mentally train your engineers in the wrong direction if you do something and not the other. And this is where security culture comes into play. And every time you take a decision or to not do something, keep in mind how this affects the security culture. And by security culture, I mean how I train the rest of the organization, the engineering and the product, to value security in the different processes that we roll out. So this is so far the first overview of laying down the foundations of a product security program. We have security training, minimal, with security best practice documentation. We do security design reviews for starting from high-risk projects and going down depending on our capacity. We launched some open source security testing tools, and we did some security testing on our existing product. And because we found vulnerabilities, we also created a vulnerability management process. On the next iteration, you can think that the product security team scales. You get more members and you get more resources. In that next phase, the goal is to expand on the different aspects of your program that you launched in the first iteration and start adding some structure. One thing that you may consider when you get more resources and you increase the number of engineers in your product security team is security partnerships. When I say security partner, it is a product security engineer that is assigned to a few engineering teams, and they become the security point of contact. Security partnerships have some great benefits, but also some drawbacks that you need to take into account before rolling out such a program. I cannot emphasize enough how great relationship it helps you build. You have security engineers working closely with engineering teams, and this really fosters a security culture, and it builds great relationships between security and engineering. Also, the whole organization has the confidence that we release features that are secure by design because we have a security engineer who also becomes the subject expert on that specific domain of the product. Now, on the other hand, if you roll out a security partnership program, you may see that some engineering teams can become too dependent on their security partner. And by too dependent, I mean that maybe they don't spend so much effort in learning some security processes that you're rolling out or some tooling, because they know that they have their security partner who will nudge them to the right direction. Also, maybe at some point in the growth of both the company and the product security team, maybe you have a good enough ratio so that one product security engineer can be assigned to a couple of engineering teams. As the company scales, this will not scale well. And this is the scaling issues I mentioned. And on that regard, I have a couple of options as alternatives, not alternatives, different forms of security partnerships. One is, instead of assigning security partners to all the teams, assign them only to teams that are working on high-risk parts of the product. Or another option is, instead of assigning security partners to projects, assign them to projects. For example, if you know that there is a new project coming up that will be, I don't know, a couple of quarters, this is a good time, and it's a high-risk one, this is a good time to assign a security partner for that project. And the second option, it helps because engineering teams cannot become too dependent, because they get a security partner only for their project and not for the whole portfolio of their team. Moving forward from security partnerships, security champions. I said that security partnerships may have some scaling issues. Security champions is the solution to the scaling issues that you will face in your product security program. My suggestion is invest in a security champions program early. I know that when you start investing in such a program, you may not see immediately the return in this investment. And this is a reason that you may deprioritize this. My advice is don't do it. It needs time to train your engineers into becoming security champions. And further down the road, you will actually see the benefits of doing that. Give them a clear path. And my advice here is don't teach them into doing web security testing. Teach them things that are applicable to their job. And their job is how to design securely software and how to implement securely software. And on that regard, train them to do some product security work, because again, this is closer to what their actual job, designing and implementing secure software. And start assigning them some responsibilities so that the training is not theoretical, but they can start applying it. Design reviews. In the first iteration, I only mentioned that following a risk-based prioritization, you will do design reviews, you will do security reviews during design. I think now it's a good time, after you've set those different practices of the security program throughout the structure we set. And in that regard, during design, I think we need to start moving on threat models. Because threat models train mentally your engineers in a very specific way in looking for threats. My suggestion is also create a template. It's you give consistent format to your engineers. They know what to expect, how to expect it, how it will look like. It helps understanding what are the threats when you have a specific threat model template. And as I said before, train your security champions to threat model. Have them shadow you in the beginning, or have them read your threat model and discuss with you how you approached it and so on. At some point, maybe they can do it with your consultation. Security testing tools. In the beginning, we didn't have budget and we rolled out some open source tooling. Maybe now it's a time to move to some commercial tools because this gives us some more rich features. I said it in the previous time we talked about security testing tools, but take time to evaluate those tools. When I say evaluate, it's not only about the quality of the findings. It's not only about the ratio of false positives. And to evaluate them well, come up with a list of requirements before you start the evaluation. And in that list, include things like tool management. Can I customize it? Can I extend it? Can I get metrics out of it? Does it integrate well with the workflow of my engineering teams? And so on. And one more thing to pay attention to is don't assess only the tool capabilities, but also the vendor relationship. The security testing tools vendors are not vendors. They are partners in our journey of making a product security program successful. Vulnerability management. I said in the first iteration, don't rush into creating strict SLAs, but we need to start putting some SLAs in place. So now it's a good time to start building a cadence of resolving vulnerabilities in time. You need to get some leadership buy-in for that, but always take a risk-based approach in your SLAs. And sometimes this means an SLA exception. An example of an SLA exception is the following. Let's say that there is a vulnerability that can be fixed within SLA in a very specific way. But there is also the possibility that instead of fixing this very specific vulnerability, the engineering team can build a more holistic solution that can harden the product on that regard. Maybe there is a good trade-off there to go a bit out of SLA to get that more holistic solution that is actually better for the security of the whole product. Another thing is build metrics around vulnerability management. What metrics each company will need is very depending on the company needs, the security culture, and so on. But there is one metric that I find super important, which is metrics on the vulnerability types. Get a vulnerability taxonomy system. It can be the CWE, which is the Common Weakness Enumeration, or any other one that has a short list of vulnerability types, and start assigning them to your vulnerabilities. What you get out of it is great metrics on where you do well and where not. For example, if you see after a while that you have too many vulnerabilities and sensitive data exposure, this is a very good data point, both for what kind of training you need to give to your engineers, but also where to focus your security testing capabilities. This is like a wrap up of phase 2 of a product security program. And of course, this is not just one iteration. There are multiple iterations to get to that maturity. But at some point, you will reach a mature product security program. And when I say mature, I mean that engineering and product know when and how to reach out to you. They know what are their responsibilities, what are the different touch points in the secure development lifecycle. You have launched out tools. There is a vulnerability management process where SLAs are being adhered and so on. This will probably free up some time from the product security team that you can use to do some hardening now on application and services. It's time that in this time you can start engineering solutions to solve groups of vulnerabilities. I have some examples here, and they're only examples. You can work on hardening against XSS, or you can do an assessment on what is your current application logging and monitoring for different security events, and then see where there is room for improvements. Or the most hot topic of the last years is supply chain attack. How well is your organization in detecting them, in preventing them? What processes do you have around it, and how can you improve? Well, these are just examples, but depending on the metrics actually you got from your vulnerability management program, you will see where you need to focus your engineering solutions to start hardening the code and the product. This is mostly what I had to share. I have some closing remarks. The first one is work on a product security program iteratively. Don't focus on solving one aspect of the program while leaving the rest unstarted. And also, by the iterations, the more you work on the program, the more you realize how you need to improve. So this iteration comes a bit naturally. Another thing is, there is no one-size-fits-all approach. What I share today is my lessons and what I learned from being in a specific company with a specific company security culture and so on. Take from that talk the things that may be applicable to the company you work for based on the security culture of that company. And I've mentioned security culture a lot, and I just want to reiterate, the company culture on security will affect your journey and will affect how successful the product security program is. So in every little detail, in every little decision, think how what you're doing actually improves the security culture of your company. How you train their whole organization that security is not only the security team's problem, but it's a problem of the whole organization. And actually, it's not a problem. It's not a problem. It's something. It's part of the engineering workflow. That's all I had to share. Thank you very much for tuning in. I'm open for any questions, and this is some contact details.
Thank you, Eva. That was brilliant. It's very sort of hard won through experience.
Thank you.
To the viewers. Madhu Sudan said the Security Champions Initiative in the team. And then the security champions maintain the balance.
This is a great question. And again, you need great collaboration between engineering leadership and security leadership. There is no right solution. Again, it depends on your company. But I think if you can get a buy-in from engineering and security leadership that X amount of hours per week are assigned to security tasks, this is sometimes it will be less or sometimes it will be more. But if on the leadership level you get an agreement, I don't know, 3 hours per week or something like that, their security champions are entitled to work on security features. This will help because usually the problem is security wants security champions to do more security, and engineering wants their engineers to actually do feature development. So I think the most important is having an agreement on what is the balance there. And what it is, the number, it depends on the company.
Yeah, I think that's an interesting point, isn't it? You know, what kind of, where do you draw the line about, I mean, we've had other speakers today talk about, you know, not trying to solve absolutely every security problem because it's impossible, right? You know, the only completely secure software that, you know, is one that actually probably has no code in it. So, you know, it's deciding, those things are always about risk versus resource, aren't they?
Exactly. Yes.
I think that was the only question on the talk. So
Thank you.
You're welcome.
Thank you, Eva.
Thank you.
I don't know what's going on with your audio. Sounds terrible to me. Maybe, is it just me?
No, I also have some issues.
Yes.
Okay.
It sounds like you're in slow motion at the minute. Perhaps try disconnecting the audio and reconnecting again. So thank you very much for joining us anyway, Eva. That was a really good talk. I very much enjoyed it. Hopefully you'll stick around for the remainder of the content today.
Yes, thank you for having me here. I really enjoyed it.
Pleasure. Right, I'm going to drop you out now. Let's see if Jamie can get his audio back together again.
Okay, you hear me?
Yeah, that's better.
There we go. Yeah, but stick with the old bows. I think the AirPods don't like it when I go out of a room and come back in. They don't get a bit antsy.
Yeah, that newfangled technology. The microphone that plugs in.
So one thing we haven't mentioned yet, we do have some sponsor offers which we can just quickly go through before the next talk. So you can visit all the sponsors in the Expo tab on Hopin, of course. So CodeFresh are offering you the chance to get GitOps certified for free. So go and speak to them about that. Sneak, if you sign up, you can use Sneak for free. I don't know if you want to say any more about that, Matt, or what that entails.
I don't know what the details are.
Okay, so go speak to Matt's colleagues in the Expo.
Speak to whoever's manning the Sneak booth there. They're far more knowledgeable than I am.
So Stackhawk are having a raffle, the chance to win a Nintendo Switch. So go along and enter that.
Awesome, I'll be right back.
Sysdig have a free trial. You can get started in 5 minutes with no credit card required. And SciCode will give you a personalized demo of the system upon request. So go and chat to all of those sponsors who've helped make today possible.
Fantastic. Right. Well, last but most certainly not least, we've got Josh Grossman joining us. Hi, Josh.
Hi there. How's it going?
You're going to see us out of this afternoon's entertainment. So Josh is the CTO of Bounce Security, and today's talk is going to be about tuning your security toolbox, right, Josh?
Yep, that's it exactly. Yeah.
Would you like to share your screen, and I will get you.
Yeah. 1 second. Okay, that's in the right place. So I just need to come down here, and there you go. Okay, can you see that now?
I can. We'll add those in. So the floor is yours.
Excellent. Thank you. Thank you very much. Thanks very much for putting on this great conference, and some really interesting talks on the lineup. So yeah, certainly been a good day. So yeah, I've come today to talk about tune your toolbox for velocity and value. The idea being, how can you get better value out of application security scanning tools? I've got quite a lot to go through, so I'll just quickly try and whiz through a couple of words about me. I can convince my clicker to work. So as you said, I am the CTO of Bounce Security. We specialize in providing application security consulting for various clients, both locally and abroad. I also do various different speaking engagements. I also do training on application security, both about the ASVS, which is I guess a pet project of mine, something I'm involved with at OWASP, and also about application security tools as well, sort of a larger version of this talk. So certainly if that's something that's interesting to you, please feel free to get in touch with me. But yeah, in my spare time, I put a few pictures up of what I get up to, but for the most part, it's application security with Bounce and with OWASP, and some hiking and family time when I'm not working. So why are we here? Why do I want to talk about this today? So with application security scanning tools, people see a lot of challenges, a lot of issues. It's often difficult to understand what exactly the tools are trying to achieve. It can take quite a long time to really get to grips with these processes and to figure out, okay, how am I going to get value from these tools? What am I seeing here? They can often provide lots and lots and lots and lots of findings we have to go through and try and triage and say, okay, is this important? Is that important? How am I going to go through these hundreds and thousands of records? And often, documentation can be a little bit sparse, certainly for, how do I deal with this? Or, okay, I've now got everything running. There's I've got a very complex CI/CD that puts everything in the pipeline and runs all the scans. But now what? How do I deal with the output? And the aim today is to try and, I guess, talk through some ideas to help with that. Quick disclaimer: your mileage may vary. Every organization is slightly different. Every organization works slightly differently. Not every idea might work for every organization, but I certainly hope that some of the ideas I talk about today will be useful for you. Before I get started on the ideas themselves, quick revision on some of the key application security scanning tools. So SCA, software composition analysis. I guess the key aspect here is it's looking at the libraries that your product is using. It's looking at the third-party code that you're using and telling you about known vulnerabilities in those libraries. You have an issue in this version, you need to upgrade to that version. This is something that's happening in library code, in third-party code. So it's not code that you've written, it's code that you've brought in from somewhere else. And you're scanning that at coding time, whilst you're actually writing. You don't need to have an application running in order to do this. SAST, static application security testing, that is scanning our code. That is scanning the code that we've written to look for vulnerabilities, look for issues. This is also happening at coding time. This is something that usually you can do, but without the application running, possibly even without the application compiling. You just scan the code and find issues, find vulnerabilities in the code that you've written. So DAST, dynamic application security testing, it sounds similar, but it's more from outside. It's more simulating a real user trying to find vulnerabilities in the application. So you need the application to be running. You need the DAST needs to be able to work with the application via HTTP as if it's as if they're a real user to try and find vulnerabilities. And that's an automated process. What there's also, which isn't really a testing tool, but it comes up a lot in this context, is penetration testing, which is looking for, also at runtime, while the code is running, the application needs to run, looking for vulnerabilities. But we're talking about a real person should be doing this. A real person is sat there manually thinking, okay, how can I break this application? How can I find or prove vulnerability in this application? So first of all, if you want a lot of great information about DAST, I'm not going to go into too much detail because Tanya did a great talk earlier on specifically about DAST and sort of very similar to some of the other things I'm talking about here for SCA and SAST. So certainly check out that talk if you're interested. Penetration testing, I've spoken about at length before. I'm not going to speak about now, but you can check out a talk that I did previously if that's something that's interesting to you. Most of the upcoming topics here are going to focus on either SCA or on SAST. Some might be very, very relevant to DAST as well, but that's the most, most of them are focused around that. And there is a lot that could be said here. I could talk for a very long time about this. My training course, I do talk for a long time about this because I think there's a lot of detail to go into and a lot of information that you can gather to help you better get to grips with these tools. But I've chosen a few key points I want to get through, focusing on how does a tool work, as in sort of understanding, well, what's actually going on in this tool, what sort of features are going to be useful to me in this tool, how am I using the tool, so how am I configuring it, how can I work with it, so what processes should I have with it, and how am I fixing issues. Some ideas for what can we do to actually deal with the issues that are coming out of these tools. So let's dive into the first section. How does a tool work? So first of all, difficult matches. This is more of an SCA thing, but I think it's quite fundamental. Now, it may be that you've got a very, very sort of modern application and using a package manager. Your package manager has a manifest that says exactly what libraries are being used, which libraries have been brought in, which versions of those libraries. And that's fantastic. If you've got that, that's great. And a tool like a software composition analysis tool will certainly look at that and use that to tell you what issues you might have in your libraries or vulnerabilities you might have in your libraries. But what if you don't have that? What if you're dealing with some sort of older legacy application? Maybe the package manager only covers part of it. Maybe it doesn't have a package manager at all. Maybe it's a lot older and it's built up over a period of time. I've seen applications where they've built a very, very large monolithic web application. They've pulled in JavaScript libraries from here, from there, from everywhere else. They've stuck them all over the place within the application. One person liked to store JavaScript in this folder. One person liked to store JavaScript in this folder. And if you're just looking at package manager, that's obviously not going to be enough. You want to make sure that your tool can look in other places as well. What is it going to do if there's no package manifest? Some tools will look for a particular location on disk or a particular folder structure. But what if that folder structure isn't there? What if just a library is there? What if someone has changed the name of the file that the library is in? What if they've changed the checksum? They updated something manually within the file, even if it's just a comment, and suddenly the checksum isn't the same. Maybe the tool is relying on that checksum to identify the library. What happens if someone has minified a bunch of libraries, they've bunged them all together into one file, and suddenly it's not 4 libraries in 4 files, it's 4 libraries in 1 file. So it's important to understand whether that is a situation for you, whether that is something you're seeing, and whether your tool can handle that. Because if it can't, it's going to become a lot more difficult to be able to identify what libraries you're actually using, and you run the risk of false negatives. So this is a widely applicable issue. But what do I actually need to do to get a scan? What do I need to do to be able to scan my application? So some scanners will work on uncompilable code. Any code fragment, you can scan the code fragment and find what you need. Some scanners might require the code to compile. They might want to compile it themselves in order to get more information about the code or how the code works. If that's the case, that's fine, that's okay. But then you do need to be able to, you can't start this too early. You can only start scanning once you've got some sort of compilable object. There are some scanners where it might actually want binaries. It might want your code to compile to binaries. And maybe that needs to be done in a special way. Maybe it's not the same way as you'd usually package them for your own testing or for your own CI/CD. It maybe they need to be packaged in a particular way. That's something to bear in mind. That's something you want to keep an eye on because it will very much affect how you perform the scanning and where you perform the scanning. If you can't perform the scanning until you've got fully compilable code and most of the code already there, that might slow things down compared to be able to run it in the browser in the IDE on uncompilable code. Alternatively, if you need to compile it in a certain way, but you're hoping to put it in line in your CI/CD, that might not work. It might be you have to have a branch off your CI/CD that compiles the code in the particular way that the scanner needs, which that's fine. It's not a big deal, but you need to be prepared for that. You need to be ready to configure your CI/CD accordingly. So we talk a lot about with software composition analysis. Okay, you'll discover this vulnerability in this library. You'll discover this issue. You can go through the reports. You can figure out what's going on. But what happens when there's a very urgent, very immediate issue that you need to deal with? Log4j is the overused and classic example. I was seeing information about that on Twitter on a Friday morning, and I was already messaging teams. But if you're going to be waiting for your scanner's database to update, and then to run a scan, and then to get the report, and then to look through the results, that's not going to be fast enough. You need a way of being able to deal with these more urgent issues as well. this sort of third-party library risk, you certainly want a tool to manage it on an overall basis. But how are you getting that up-to-date information? How are you going to get that, okay, you need to deal with this right now? Maybe you have a threat intelligence provider who can help you with that. Maybe your SCA vendor can actually give that to you. Maybe they have that information for you through an alternative channel. I'm going to get laughed at if I say Twitter, but it's not a terrible way of finding out what's going on. Twitter's a very good way of finding out what's going on in the security world, very up to the minute, or other people's security blogs, or other sources of information. What will help, though, is if your SCA tool is preparing some sort of inventory or software bill of materials, then that's going to make it a lot easier to investigate this sort of issue and to discover, am I actually using this library? Where am I using this library? So that's certainly something to bear in mind. So next I want to talk about the usability and the interface. So there's very much an idea that we want to try and bring information from these tools into a developer interface, into something sort of ticketing system that they are used to already, that they're not having to look at a different pane of glass, they're just looking where they usually look. I think that's fine. I think that you should get there. That's certainly the direction you want to go in, but it's not necessarily where you're going to start. And I think you are going to spend time having to look through the interface of this tool to make sure that, first of all, you understand exactly what's going on with a particular finding. You may need to go through this interface in order to get rid of a whole load of initial results that trim down some of the noise. You may need sort of the more advanced features that the user interface might provide. If you've done a SAST scan and you've got a finding relating to some sort of code flow where input comes in here, goes through these 14 functions, and then goes to get an exploitable function further down, you're not going to capture that in a ticket very easily. You probably are going to need to go back to the interface to understand that. So you want to make sure that whatever tool you're using, the interface is usable. You need to be able to work with that and be able to feel comfortable working with it. Just relying on tickets in some other system is probably not going to be enough for every use case. So that's some thoughts about, I guess, features of the tool. But so what happens when we come to use this tool? What do we need to think about when we're actually using it? So in any sort of reasonable sized organization, if you try and bring in a tool like this, or you're using a tool like this, someone's going to want to know, how are we doing? How are we performing? Are we improving? Are things getting better? Is the smiley, is the smiley face up, or is the face pointed down? If you don't, I suppose, decide up front what you want to measure and how you want to decide this, someone's going to decide it for you. Someone's going to look at a number, say that's now the number that we rely on, and all our KPIs and all of our business processes and assessments and enforcement is going to revolve around this number. So it's something that's important to think about up front to make sure you know how are we going to measure our progress in this. So in terms of how is the tool doing, which is it's definitely an important part of this, you may want to look at the quality of the data that you're getting from the vendor. How good is this tool? How good is the data that we're getting from the vendor? How much information we're getting that we couldn't get somewhere else? If this is an SCA tool, how many vulnerabilities are we seeing that we don't see in NVD, or which have additional information that help us make better decisions that we wouldn't see in a publicly available data source? How long does it take to actually run these scans? Is this slowing us down? Is this causing everyone big headaches? We don't want to make people sad with this. We don't want to make, especially we don't want to make developers sad. We don't want them to associate the security tool with a bad experience or a slow experience. We might want to consider how accurate is the tool. What's the ratio of false positives that we're seeing compared to real results? Are we identifying false negatives? A classic example might be if you do a penetration test, for example, somewhere down the line, and they find a vulnerability, and you're like, well, that's weird. Why didn't the SaaS tool find that? Maybe you discover that your SaaS tool just didn't pick up on this. It should have seen this in the code, but it didn't. That's an example of false negative. For SCA tools, that might be missed libraries. Okay, we know we use this library, but we're not seeing it here. Or why not? And again, we're thinking of ways we can track, how is this tool working for us? Is it doing well for us? If we are seeing that we're not getting the value from it, or we're not getting the speed from it, or we're not getting the accuracy that we need, that might be an indicator that the tool isn't doing what we needed to do. So the other side of this is, how are we doing? Are we performing well? Are we managing to progress on the findings that are coming out of this? Now, it's very easy to just look at the very sort of, okay, this is the current number in the tool and this is how we're doing. And if that number goes down, then it's good. If that number goes up, it's bad. It's certainly more complicated than this. I think I'd certainly recommend saying, well, what do we expect to happen? What's our commitment? How fast do we expect to fix things? Or within what service level agreement do we expect to fix things? And then bring out numbers that compare performance to that. So we've got some sort of baseline expectation rather than just looking, does number go up, does number go down? I'd strongly suggest splitting out between what are these issues are new issues and what are these issues are fixed issues. It's not just a number change, it's also how many do we fix and how many are new. So we know, okay, well, we made progress, but there are new vulnerabilities that come up. Maybe the database got updated. Maybe new vulnerabilities came out for a particular package. So we want to capture that information, otherwise it could be quite demoralizing if we just see a number going up without capturing the fact, well, actually we did a lot of work to fix things this time around. It's worth tracking how we fixing these issues. If we're doing a proper remediation or an upgrade, which I guess would be the best option for SAST and for SCA, where we actively fix it in the way that the tool expects, then that's great. If we're having to use some sort of other mitigation, some other method of making this better that's not the exact way we're supposed to, then we probably want to track that. And just if we're always using mitigations and we're not using the best possible way, the best remediation, and we're not doing the upgrades, then it might indicate that we're struggling a little bit with our process and that we want to rethink how we're actually addressing these. I'd strongly suggest also picking out not just numbers of issues, but also what types of issues are we seeing. Are we seeing issues that recur over and over again? Can we use this information to drive our training? Do we want to push our developers to spend some time learning about these particular areas? If we do training and we see these areas are still returning, maybe there's another issue. Maybe the training isn't good enough. Maybe training hasn't given them the information they needed. So certainly we want to use this to, improving our numbers here isn't just about fixing things, it's also about stopping them from happening in the first place. And we can use measuring our performance to help with that. So there are lots of different parts to this process. Who's going to actually implement it in the first place? Who's going to install the tool and set everything up and get everything running? Who's going to make sure the scans happen? Who's going to build those into the pipelines? Who's going to fix the issues? Who's going to deal with the issues when they come up with the findings? And who's going to review the results and prioritize and decide, okay, this is the order in which we're going to fix. This is where we're going to start. So in a lot of organizations, I think the risk is that the answer to all those four sections is, well, we'll get the security person to do it. This is a security tool, so it's a security job. It's a job for the security person. It's important to share the love a little bit here. Everyone has a role to play here, and by expecting the security person to do all of these, then I think we're pushing them outside of what they're actually good at and what what we should expect from them, and I guess taking time away from them doing other more practical tasks that are suited to what they want to be doing, what those security people need to be doing to maintain the security of the product. In terms of implementing, maybe needs to be someone who's familiar with the tool, familiar with the overall processes, but also maybe a more technical IT style. There's very much sort of a practical element there. It may be that for particular policies, particular configuration, they want to consult with security, but it's not necessarily a security function. Similarly, for running and maintaining the scan. So that's very much a DevOps job in terms of, okay, we need to put this into this pipeline. We need to set this to run after this. We need to get the results pulled over to here and integrated into that. Again, this isn't exactly how that happens, or the specific configuration or the overall plan. Again, can consult with security, but the actual hands-on who's going to do that, that's a DevOps thing. In terms of reviewing and prioritizing results, this is probably where you want the most time from your security person to be spent, because this is where their knowledge really comes in useful to understand, okay, here's where we need to start, here's what we need to do first, here's where we need to start, here's what's most risky to us. Because then when we get to fixing the issues, that's ideally someone who's really familiar with the code, the developer, the architect, someone who's down in the weeds of how all this code works, or and can understand, okay, well, this is what I need to do to make this work better. This fix will work. This fix won't work. And again, everyone here can consult with a security person, but we don't want to expect that the security person is going to do all of this, because it's going to put a significant burden on them. And again, they don't necessarily have the bandwidth for it. I think it's also important to include everyone so that everyone feels they have some sort of involvement and buy-in, because ultimately this is trying to benefit everyone. It's not just to benefit the security person. And speaking of buy-in, none of this is going to happen from the bottom up. If you have security people sort of running around developers trying to get them to start using this without any sort of management expectation, that's actually what's going to happen. It's not going to happen. There's another trope that security is everyone's job. Well, everyone's job is what their job is. Their job is defined by their manager, and the manager's manager defines what the manager's job is. We very much take the cue from up top. If management aren't pushing this, if this isn't clearly a priority for group leaders, for VPs of R&D, CTO, however it works out, then it's not going to get done. And I don't think there should be an expectation it's going to get done. Ultimately, they're the ones who define the priority. It's certainly not up to security to chase around and try and make this sort of thing work. It's another thing that's just going to create a negative view of security, where security is seen as the police chasing around trying to enforce the law, whereas they're not getting any backup, they're not getting any input from the actual management of the people who need to be doing this. And that means we need to make a way of measuring it. We need to make sure we understand, is it happening, is it not happening? Are we on target? Can we provide management with information showing that so that they can then take action if necessary? And what's the process for saying, look, we can't do this right now. We can't deal with this issue, but we will deal with it then. And providing some sort of explanation about, okay, we can't do this now, but we are going to do it next week, next month, next sprint, however it needs to work out. But it needs to be a clear process that this is, whoever needs to do this understands that it is their responsibility to do it. They have buy-in from their boss. They can ask their boss to prioritize for them if necessary, but it's something that's coming from their organization. It's not just coming from security causing everyone a headache. The final point here, I mentioned how early can we do this. If we can do this already in the IDE whilst the developer is writing the code, then that's fantastic. If we can, once we've written code, compiled code, sent it up to CI/CD, packaged it, scanned it, got a report, sent the report back to the developer, who knows what the developer's thinking about next? Maybe they've moved on to the next feature. Maybe they're just not thinking about it anymore. Depends how long it takes to come back. If we can give them immediate feedback in the IDE that says, look, you've just tried to use this function, you've just tried to use this library, there is a problem, you might want to look into this, then they're already in that context, they're already in that mindset, and they're much more likely to be able to fix it there and then. You're going to need to tune that. You don't want to have too many sort of false alarms. If they're constantly getting security pop-ups flashed up at them, like this one that I made up, then they're not going to want to deal with it. They're going to say, continue, let me get on with it. None of this is ever helpful anyway. It needs to be targeted, it needs to be well-tuned, but it can certainly catch a lot of things in the bud. Probably can't catch everything, and there shouldn't be an expectation that if everything's clean in the IDE, then it will go to the report, the full scan, it'll be clean as well. But it can certainly catch some of the low-hanging fruit. So that brings us on to the more specifics about how are we actually fixing these issues. What do we how can we actually do this in a more efficient way? So the first thing I say is you do not want to switch everything on at once. Do not suddenly search for absolutely everything. Do not suddenly raise alarms on every single vulnerability in every single library. Do not suddenly scan for every single possible code quality issue and, I don't know, brackets on the wrong line issue from your SaaS tool. You need to take a phased approach. These tools will put out a lot of results if you let them, and suddenly seeing, okay, I've now got these 1,000 things to look through or 100 things to look through is, so that's a big, it's going to cause a very, very bad impression of the tool. It's going to cause bad feeling from the tool. You need a plan for how we can do this gradually. Let's start off with the most important things. Let's start off with what we're really worried about. Okay, we'll fix those, we'll get those dealt with, and let's move on to the next ones. Each time, more findings will trickle through, and that's fine. As long as it's on a more graduated basis, I think it's going to be easier to have that. how do you know which findings get the best signal to noise? So, which ones are you getting the best results? Which ones are you constantly not going through and saying, okay, false positive, false positive, false positive? Choose some that are real and need to be dealt with, and you see from the initial results, these generally come up with real issues. Which findings are highest risk? Maybe that's based on the tool, maybe that's based on the application. You need to try and find that balance, but again, you need to find a way of phasing that in. So I may take a lot of grief over this, but I would certainly recommend trying to upgrade early and upgrade often. If you can upgrade even before waiting for a vulnerability to be in your libraries, then that's even better. Let's say, look, we want to keep these libraries up to date so that if there is a vulnerability, maybe we've already gone past the vulnerable version, or maybe it's very easy for us to upgrade. We certainly don't want to get stuck in a situation where we're 3 major versions behind and suddenly a massive vulnerability comes up and we're suddenly under pressure. That can be a lot more difficult. It can be even more difficult if this is a product that we're actually deploying to someone, and now we have to support maybe 3 years worth of this back as well. This is a whole debate, this is a whole sort of discussion in itself, but you really must try and upgrade wherever possible if you want to avoid ending up in these situations where you've got a lot of work to do in a short period of time in some sort of security emergency. It's also a lot easier than actually trying to analyze these vulnerabilities in depth. If you have to say, okay, we can't upgrade this now, so we now need to do some sort of risk assessment and understand what's our real risk from this library. There's a lot to go in there. There's a lot to try and understand there, and it's going to, trying to do that on a grand scale is going to be hard work. In terms of where do we start? Do we want to start on easy to fix issues? Do we want to start on the harder to fix issues? Easy fixes give us better numbers, maybe easier, but the harder to fix issues, maybe they're the more, they have higher impact, potentially achieve something more significant, and we don't want to wait and suddenly have to do this in a hurry. I would say do both. Try and blend in a particular period of time, do some easy, but also keep moving on the hard ones as well. You don't want to just choose one of those. You need to keep those numbers moving. You need to keep getting through the easy ones, but you do need to start and make progress on the hard ones as well, so they don't get left to the end and suddenly you're in a massive rush to fix them as some new vulnerability comes out. Think about how to remediate things strategically. We don't just want to fix one line of code in one place and then next time the finding comes up, we'll do it again. Let's think how we can do this at a wider basis. A classic example of this is trying to centralize some functionality. I had a client where they had 150 different issues about log injection in their SaaS tool, because every time they did logging, they got a vulnerability about this, and they thought they cheated. They thought, okay, well, we'll put all our logging into one function, and we'll create a wrapper function, and then the scanner doesn't know about this wrapper function, just knows about the logging function. So we've changed 150 vulnerabilities into one vulnerability in one place. And I said, that's great. That's exactly what you're supposed to do, because now you can do your sanitization for log injection in one place and just always use that wrapper function. And then you know that it's going through the wrapper function, it's being sanitized, and you don't need to worry about it. Any way you can do that is going to make it easier to centralize and manage your controls. Alternatively, if you can say, well, look, we've got some functionality that works in a less secure way, maybe we can just swap that out for newer functionality that works more securely. It may be a lot of work, but it may be that overall it makes it a lot easier to secure the application and a lot easier to avoid shooting yourself in the foot with something. A classic example could be, instead of dealing with secrets locally, have some sort of dedicated secrets management service that handles that for you, handle the encryption operations, key management. Suddenly you've taken a lot of things that you could potentially get wrong and moved them somewhere else. But how do we make sure that happens in the future as well? You need a safety net. You need something that's going to make sure that the wrapper functions are being used, the external functionality is being used, and if someone tries to use the original function or tries to use the unintended functionality, then it's popping up alerts saying, you might want to check this out, they're not using what we expect them to be using. This is the idea here is to make these things easier. Wrapper functions, externalizing the functionality to a dedicated service. We've centralized our security risk, we've centralized the controls, easier to manage, but we just need to make sure that's being used on an ongoing basis. So that was quite a fast tour. I hope all those issues were useful. Hope those ideas are useful. Like I say, not everyone might be relevant for every single person, but yeah, I hope that you can use these ideas to try and improve the processes and just make it easier for yourselves and make it easier for developers and generally get a better experience from these tools. So yeah, thank you very much for listening, and let me know if you have any questions.
Thanks, Josh. That was great. Oh, we have got a couple of questions for you, in fact. So, firstly, from Juan was, if you only have budget and time to do one thing, what would it be?
Company away day in the Seychelles? No. So, as in one type of tool?
I guess that's what the meaning is.
Yeah.
Like you do SCA or SAST or whatever.
SCA or SAST. I think there are different risks here. I think that you can go all in on a particular tool, and you can spend a lot of money with a vendor, and you can you can get something very sophisticated and start building very sophisticated processes. But I think that if you go all in on one, then there are other possible risks you're not covering. I don't think it's an easy sort of trade-off to saying you should do this and then you should do that. I think you're exposed to risks either way. If you're that limited on time and budget, maybe you need to start off with something simple for both and sort of progress gradually. I think that just saying we're going to do this and not do that, I'm not sure that's a decision you can necessarily make. Certainly for for all of these tools, there are freeware versions that might not be super pretty for developers, but will give you some sort of position without starting paying license fee. I think the important thing is to have some sort of perspective and some sort of control around all of these, even if it's relatively rudimentary. I think you're going to struggle to say, no, I will start here, and then we'll just ignore this area completely. Yeah, it's a tricky one, but I think you can't necessarily just rule out particular issues or particular type of issue, because it can all of it can cause you risk.
And then one last question from I think we're both clicking a button at the same time, Jamie. Mark Johnson, if security isn't a priority, I assume it means in your organization, what advice would you give to approach management to get more support on security?
I think we have to try and demonstrate what is our risk here, what is our exposure, what could go wrong. This isn't necessarily this isn't a threat modeling talk, but a lot of it comes down to maybe even sitting people down and saying, all right, what could happen here that would make us really sad? What could happen that would completely ruin our day? And it maybe on a scale of what would give us a bad day, what would give us a bad week, what would cause us like significant monetary harm, what would end the company. Every organization has risks that affect it and that are going to is going to have to consider. Odds are, if they have some reliance on software, then software security risk is going to fit in there somewhere. And I think that hopefully by demonstrating the link between what is going to make us really sad, what is going to end this company, and bring that link back down to, well, what are our practices today? How could that happen based on our current practices, or how could that happen without doing X, Y, and Z? Then hopefully that becomes an easier conversation, because you're directly linking it to what are management worried about from the business perspective. And look, maybe you have to start small. You have to prioritize. You have to say, well, we're just going to focus on this particular application, which has which management are particularly concerned about. We're just going to focus on this particular type of issue. But I think the key thing is to link, what is going to make management have a bad day, what's going to make that company have a bad day, and linking that back to what you're trying to achieve.
Yeah, great answer. Thank you for that, Josh. It was a great talk, super interesting, and thank you for joining us.
No problem at all. Thanks so much for having me. I really appreciate it. And yeah, thanks for the really interesting conference.
Right, so I'm going to drop you out now. We've got Andy Martin just come back to get all the plaudits at the end, right?
Congratulations. Excellent job, everybody.
This is it's pretty much the end of the road. I don't know about you guys, but I'm ready for a lie down, I think, in a dark room somewhere. But before we go, so some thank yous. Thank you once again to all of our fantastic sponsors, Sneak System, Contrast Security, CodeFresh, MuleSoft, StackHawk, Bright, Sidecode, and Blue Bracket, without whom this conference could not go ahead. Thank you to my fantastic co-hosts, Jamie Thomas, Andy Martin from Control Plane. And I'll see you in Austin next week, Andy.
I look forward to it immensely.
Excellent. It's hot, apparently, over 100. So I'd bring you shorts if I was you. Thank you to everybody who's watched this EMEA section of DevSecCon24. The Americas section, hosted by my very good friends Eric Smalling and Brian Clark, will be starting in just less than 1 hour. So if you do have time, I'd highly recommend coming back to see us or hanging around until then. I had a quick look through the schedule this morning. Looks like there's a whole bunch of really great talks. Again, particularly in my space, in the Kubernetes space, Lewis Denham Parry talking about threat modeling Kubernetes. I'm not quite sure how he's ended up in the Americas time zone. Obviously, Cardiff has changed since I was there last. But that'll be great. There was also some stuff about CI fuzzing, which I'm also super interested in. A whole bunch of other fantastic talks. Thank you to all of our speakers today. Again, without people putting their hands up and writing talks and coming to talk at these things, obviously conferences would be fairly boring, as we wouldn't be sat here for 4 hours talking nonsense to each other. So I think that is about it. So at this point, yeah, thank you, folks, for watching us, and hope you hang around for the rest of the conference. And now I've just got to click this button, I think.